morning all. Everybody, I believe, and welcome to the Construction Worker Housing Division. The Construction Worker Housing Division addresses the real problem of construction workers in India. We know that construction workers live in a very condition that is not so good healthily. They are not given comfort. They don't have hygiene and safety. And most of the often times, women workers are hit the most. So the participants in this division have understood their problem and attempted to provide good quality housing for the workers. I'm excited to welcome all to the Construction Worker Housing Division to find out how these students plan to transform the lives of the construction workers in India. My name is Arithro and I will be emceeing today. It's my job to keep us all on time and I will take it very seriously. Our finalist teams have put in a lot of hard work. They have submitted their project reports 1 month ago and today they will be presenting their work in front of the jury. Today we have, in this division, we have 3 jury members who have an expertise in net zero and resilient building. We have Saswati Chetia, Director GKSPL. Next we have Moni Sripurapu, CEO and founder and studio. And a 3rd jury member, Nilesh Sonavane, Business Development Leader, Owens Corning. These jury members have had about 3 weeks to review the reports submitted by the teams. They have looked at the work in detail and have assessed their work on the 10 contests of the Solar Decathlon India competition. Team, your presentations today will give them a view of their narrative. Also, they will assess your presentation and the mastery of your solution through the Q&A session. They may revise their scores if needs be. I am excited to have you today meet the teams. I will interrupt you if needs be, including the participants here, the jury, and anybody else present in the room. Please don't mind. And please, I'm looking for the support of everybody else to keep us on time. And so, okay, ready? Are we ready? Let's start with the presentations now. Our first presentation is from Team AKM. They worked on a project named Suki Bava, located in Udupi, Karnataka. You are ready, people?
Yeah.
So team, you will have 20 minutes for your presentation. At 15 minutes, I will ring a bell like this. Okay. You will not have a 21st minute for your presentation. So that means I will stop you and say to end your presentation at the 28th minute.
All right.
So are you ready?
Yes.
After that, we will have 10 minutes of Q&A session. And keep your answers direct and to the point.
All right.
As much as possible. So you can start your presentation. It is yours.
Good morning, everyone. We are Team AKM from Manipal School of Architecture and Planning, collaborating with Manipal Institute of Technology. We are today here to share our journey on designing construction worker housing. Hi, I'm Samar. With me is Nilaya, Anshula, and Kushagra. We are a team of 15 members from different. We are from BARC, MTech, and BDES, interior design. Our team ideology is Suki Bava, which means joy and happiness to all. At the starting of our journey, we started with a question: who are the construction workers, what they are going through, and what they need. Construction workers are the unsung artisans transforming raw material into the elegant structure that shape our world and dream. But today they are living in very poor, unhygienic condition. They are vulnerable to different diseases. They have social isolation. With all these, we started our journey. We collaborated with Grassland, which is a developer in Udupi. They mostly develop residential complexes. They gave us a site for a construction worker housing of 2,490 square meter, where 250 workers are to be set for 24 hours and a time duration of 5 years. The site present is in Udupi, which is connected to NH66 via service road, providing easy access. The major wind directions are from east and west. The other sides, north, south, and east, have a dense vegetation. Achieved ground coverage was 830 square meter, and total built-up area we achieved was 1477 square meter. The site lies in warm and humid climate with average rainfall of 4,535 mm and highest temperature of 36 degrees Celsius. We went with some passive strategies like openings, vegetations, and verandas to make our modules more comfortable. We set 10 goals to achieve, which we will talk. Now the site, the main challenge at the site was it was narrow and it was inverted L shape. And hence we went with a rectangular module which was set along the site boundary with common spaces like kitchen, dining, and the first aid room in the center to cater the needs of both the sites, and other amenities like toilets, washing area, bathing area on the two ends. There are 3 axes to the site, including one service axis, which is at the end of the site, which is connected to the 8-meter wide road in the main construction site. Our modules are 6 into 4 meter with an additional veranda of 2 into 4 meter with 8 people with maximum 8 people living in one module. Our kitchen and dining is 12 meter into 6 meter attached with kitchen and dining are attached together with a space of 100 to 120 workers at one time. We have also provided first aid room and electrical room on this site. The major material we used for construction is bamboo, which is used for roof, truss, for wall panels and flooring. The structure framework is done of mild steel. The exploded view shows different elements in the module. The left one is for single and the right one is for double story. We have used simple joinery details to make it more user-friendly to all type of users, reducing the spatial skill requirement. The wall panels are actually sandwich wall panels with Magra insulation in between and a waterproof layer. The roof panels are half split bamboo with waterproofing layer, and the floor panels we have used bamboo for reinforcement as well as stripes of bamboo to give it a smooth finish. The solar panels are fixed upon adjustable framework which gives option to change the angle whenever required. We have chhaja on 2 different sides as other 2 sides already have veranda. Now the question is why we used bamboo. So we have used bamboos which is available in major part of India. Also bamboos are affordable, reusable, lightweight, sustainable, flexible, and also we compared bamboo with other materials that are available in market, as shown in the graph, and hence we decided to go with bamboo. All the elements of the bamboo are being treated before use to make it more fire resistant, more termite and waterproof.
Okay, so now let's see what we have in our modules. Focusing on an easy assembling and dismantling method of the modules, we analyze that it takes around 7 to 8 hours with 4 to 5 people for assembly time of one module, and 14 to 16 hours for a G+1 structure. We also took care of the transportation, so there's easy transportation which reduces the material size and the transportation cost as well. So our modules are all about adaptability. So the users can change the size, shape and form of the module to according to their needs. The furniture that we provided is also modular. In our modules, we have included a venturi wall. So we have a veranda which has a venturi wall and eco coolers with them to just change the hot air, incoming hot air into cold air. We use bamboo and magra sandwich panels. So bamboo and magra is a very unique combination. If you see, it's also very lightweight, durable, it is cost effective and also helps to reduce carbon emissions. We also use a dehumidifier in the modules which lasts a year. It's bamboo charcoal which lasts a year if you put it near the sunlight in a 24 square meter room. So comfort of the workers is our major priority. So to reduce the thermal stress, we provided them with natural ventilation methods, green wall, health relief zones like veranda, and vegetation provided. We also took care of the shading and daylighting. Health resistant infrastructure which includes magra, which is also a VOC less emission material, which is basically a natural material, so we don't have much toxicants in the module. So, we have a lot of safety in our site and provided with a first aid room and ambulance on site. Okay, we also used plants like lemongrass plants and lemon balm plant, which keeps away the pests, and mosquito mesh is also provided there. Provision of kitchen and safety. Kitchen ensures the food safety, and we also provided with street light in the pathways during the night time to prevent any accidents. For resilience, our module can withstand load of earthquake till zone 5. We have a swell and plinth for overflow of water during heavy rainfall. Can also, during any pandemic, our modules can be in cluster form and can be used for isolation as well. During windstorm, we also have cross ventilation method because of the way we placed our windows. Here we are showing you how our emergency exit of our site is. And also for zero waste management, we use biodigester tank. And for safety, for fire safety, we have extinguishers available, and also for safety and security, we have CCTV cameras, a chain link fencing, and also street lights as mentioned before. So our waste management happens in 3 types of waste. One is biodegradable, non-biodegradable, and also medical waste. Talking about transportation, we have a 21 ton carrying truck available, which can carry up to 3 modules of our 3 of our modules in the site.
Now let's look into how our modules are how our modules are performing in the case of energy, water, and embodied carbon. We have achieved an EPI of 17.97 kilowatt hour per meter square per year. And this accounts for 36% decrease from the base case of 28.08 kilowatt hour per meter square per year. We have achieved this using major strategies such as using bamboo magra sandwich wall panels that has improved our thermal comfort. We have used verandas and corridors as shading devices. We have also switched conventional electrical appliances such as lights and fans with more energy efficient options. When it comes to thermal comfort, we have 2991 additional hours of thermal comfort when compared to the base case, and we have also attempted to simulate our modules in different climatic zones of India. To achieve net zero, we have installed or proposed to install 16.35 kilowatt solar panel system, which occupies 77.4 square meters of area. When it comes to solar incident radiation, we have again used verandas, corridors, pitch roof with overhangs to reduce the incident solar radiation by 500 kilowatt hour per meter square. And since the CWH units are used majorly during the night time, our daylight requirement decreases, and this is why we do not have that need of daylight as in other buildings. But still, we have used verandas again to allow for glare-free light to enter the spaces. Every drop of water counts, and here's how we have achieved 54% in decrease in 54% of water consumption as compared to the base case. Our per head per day consumption of water is 62.5 liters, and we have achieved this using water efficient fixtures and educating and spreading awareness regarding water consumption. Using rainwater filters by our industry partner, Farmland Rainwater Harvesting Systems, which is 90% water efficient. Groundwater recharge through swales, biotoilets and biodigested tanks, grey water treatment. We have achieved 164.11% net positive in water. Coming to embodied carbon, we have reduced our embodied carbon in walls by 81%, 97% in roofs, 87% in floors, 86% in fenestration, and 53% in structure. In all, we have reduced it by 76.43%, and this we have done through use of sustainable materials and sourcing them locally.
Up until now, we have addressed the problem and we have talked about a proposed solution. Now is to talk about implementation. Keeping the versatile nature of our module in mind and to broaden our reach, we have devised a business strategy. Showcased is a proposed business model for a construction worker housing module. This module allows us to cater to a large audience through its different purchase options such as EMI and rent model. Coming to some details, it would cost us about ₹1,28,000 to manufacture a module, and we have set the selling price at rupees 1,61,000, which gives us a profit margin of 25% necessary in order to help us manufacture more units. In addition, an installation and shipping cost of rupees 12,880 would be charged if the service is required. The payment structure works in a way that rupees 15,429 would be charged in the EMI model and over a period of 12 months, and the rent model is rupees 6,700 rupees per month. Minimum rental period would be of 3 months, and an additional 10% discount would be given for a rental more than 12 months. Now let's see how affordable our module is. With specifications of a project in mind and taking reference from Karnataka schedule of rates, the cost estimate concludes that the project cost or capex is rupees 6,086 per meter square, which is about 49.8% lower from the baseline scenario. We have achieved tremendous savings by managing to accommodate the construction workers within the site itself. This saves the project partner the extra cost of leasing a land and to accommodate the construction workers as happening currently. Keeping in mind that we have proposed a monthly rent of rupees 6,030 and that the module accommodates 8 construction workers at a time, the workers only need to pay rupees 25 per day or 4.2% of their daily wages to improve their living conditions and lifestyle. These improved living conditions are not only affordable but are also thermally comfortable with an operative temperature of 27.5 degrees Celsius. It is also sustainable as it reduces embodied carbon by 76.4% and is spacious as per NBC guidelines. It also achieves net zero energy by the use of solar panels and 164.11% net zero water with rainwater harvesting. Moreover, it also achieves few sustainable development goals by the UN as stated. Due to its temporary nature of investment, the worker housing is a cost-sensitive topic. Team AKM mitigates this by prioritizing modularity, scalability, as well as ease of assembly and disassembly, thereby making it a safer investment option. From the project partner's point of view, providing this housing facility for 5 years would cost him about rupees 68 lakhs. Since we have proposed rupees 25 a day for the construction workers and the project goes on for 5 years, the project partner would earn a return on investment of rupees 48 lakhs with a payback period of 3 years. We believe that user satisfaction is the ultimate goal. After the completion of our design, Team AKM went to 5 different construction sites and interviewed about 42 workers and asked them how they feel about our design. The showcased graph is our little survey. Today, after 9 months of hard work, we believe that it is not the end of our journey. We believe it is the beginning of something even greater. We leave this stage motivated to continue our efforts and fine-tune our design. We hope that one day we can create and ensure a feeling of comfort, safety, as well as belongingness and dignity within these underappreciated heroes, the construction workers. With the remaining time, I would like to distribute some pamphlets and we have designed and also the project partners letter to the jurors. I would like to thank the esteemed jurors, the audience, our project partner, our industry partners, as well as Solar Decathlon India for providing this stage today. Thank you.
Thank you, team. Some interesting use of bamboo into the project. So, now let's move on to the jury for some comments. Yeah. So I'll start with you. You can go on.
That was the main comment which we had made. But just try and understand, we are not constructing, very luxury residence where there are bamboos. We are constructing for a target audience where, smoking will be very common habit. And that's the whole reason a little bit concern about usage of too much bamboo, unless, you say this is what is the fire treatment which is available, and such kind of incidences will not lead to fire. Do you have any specific fire treatment which you can elaborate?
So we went with a treatment with boric acid, and we also consulted our, the faculty members and the site engineers for whom we are working, and we discussed with them. So they were fine with it, and they told like it has enough fireproofing to hold. In those small cases like smoking and all, it has enough fireproofing. No, sir, we didn't actually try it. Yeah, yes, sir.
One second. U value calculations. You have shown roof 1.99, roof is 2 point something, and floor is max. Meaning, it needs to be which is better performance. Any specific reason you have kept least thermal resistance for the roof? It should be other way around. Because your heat ingress happens from roof and wall in clad, and then fine, floor, unless it's very very cold climate, you don't keep the values, U values too low. It's good that you have pretty thick, but then my point is, let's say for roof, you had that luxury to reduce the heat ingress by increasing thermal resistance or reducing your U value,
So
which is conductance. Yeah.
when it comes to bamboo, we have focused on availability of material.
Okay.
And since bamboo is readily available, and focusing on the affordability part, we looked into how it's performing in comparison to base case. So you have a U value of 5 or more than that in the case of GI sheet roof, and you compare that with bamboo's 2.39, it's a winning situation in this side.
And also, sir, we have like used solar panels over the roofing, so it will reduce the incoming heat.
Can I think let's discuss a little bit more about bamboo, because it's the most prominent the feature in your design. First of all, I think before going into the comments, you guys have done a tremendous job.
Thank you, sir.
And the amount of work that you guys put in is really good to see the depth that you went into, and also collecting all the experience from the people and trying to understand their problems, and then actually reflecting on the design is a very good approach.
Thank you, sir.
And but the material that you're talking about, right? I think that's something. Let's understand like how. So you are 4 of you here, and the team is much larger. So who was working on bamboo from your team?
Sir, bamboo, sir.
You were the one who's working on bamboo.
Sir, I was majorly involved in
the bamboo
architecture.
thing. Okay, so the species that you spoke about.
Yeah.
So you said it is readily available in the presentation in most parts of the country.
Yes.
Are you sure about it?
Sir, I mean like the source that we went with, it was there, and also in Udupi we went with like the government sites, so it is there available.
Available in
Yes.
Udupi
Yes.
for sure, but
Yes.
but it's not a common species.
It is a common species, although it's like for example, if you say Karnataka, so in few parts of Karnataka it's available. Then in other states, it depends on the the temperature or the soil.
Just to clarify, I mean the species that you picked is perfect, in the sense that as for construction, bambusa is the best material for sure. But generalizing it and saying that it's available all over the India, that's a big statement. You should not make such statements, because it is not that widely available. And but if it does, it's a great material to work with. And you since you used it extensively everywhere, so what is the life of it? So because how long do you think the material will last? It's exposed everywhere. Yes. To sun and all the elements.
Yes. So like if we take a normal bamboo, it goes for like 2 years, 12 to 36 months. But when we treat it, the life increases the bamboo, and also we have introduced like the waterproofing layer on the surface of the bamboo, so it doesn't get exposed directly to the water.
Also, I would like to add that it is a kit of parts assembly. So the bamboo panels, if broken or damaged, it can be easily replaced. So that is there.
That's a good comeback. But when it is exposed to sun, especially with bamboo, if you look at all the tropical architecture where bamboo used extensively, it has good overhangs because then the material is not exposed to the sun. The one big problem that you'll find with bamboo is splitting with sun. It splits over time, and that's very common in decoloration. Decoloration, you can't do anything about it, but this is something, and also the problem with fungus and termites. So have you considered that in the design?
Yes, sir. We treated the bamboo using, as told, like boric acid and other chemicals.
That's for fire, or that's for?
So it take care of termite also, sir.
So which treatment did you use for that?
So borax or boric acid we are going.
What's the method of treating?
So bamboos are submerged in the
Submerging technique.
yeah, submerged for a few days.
Okay. And for the flooring, that's, I think, for me, of all the things that we spoke about, like in terms of the application of it, the biggest questionable thing is the flooring part of it, because that's where the a lot of traffic, the usage and all that, and also like if anything drops, whether it is cigarettes or someone cooking, which they should not be doing, but in case if it happens, or heaters that they use typically, which people put on the floor, it could cause major fire accident. While I think the walls and the roof, what you did is definitely it's great, and but for flooring, I think my personal opinion is that you could have gone for a different choice of material, or layer on the top as a protective membrane, something, while this substructure could have been bamboo. That was one observation. And
sorry, Manish.
Yeah,
I will like to stop you for now. We can go with
Okay, one question just to understand that this, because at the end you also talked about the whole module cost and how much you will sell it for and all of that. So this is it something that who's going to manufacture it? I mean, what's your plan? Like, who's going to manufacture it, and then you'll sell it to what different builders for their construction workers, housing? How is it that you have thought of?
We plan to collaborate with different industry partners.
Mm-hmm.
We are already collaborating with 7 of those. We need to look into more of those, and then we can specify which industry partners are responsible for manufacturing of what parts. So they will be responsible to export and
including the wall panels and everything.
Including the
because
wall
you see, your wall panels are your bamboo strip, you have the magra, this thing. So
yes,
that has to be made into a composite thing to be able to, you said, construct the thing in, I don't know how many hours. You said 7 to 8 hours or something like that?
yes.
Right. So these things have to be, everything has to be prefabricated, right? So I didn't see like, okay, now you have just brought in the components from different industry, this thing. So you're getting the insulation from somebody, maybe the bamboo from somebody, but your thought process probably is that, you'll have to get it compositely manufactured. One last question is that in your energy performance thing, you had mentioned that X number of comfort hours we increased.
Yeah.
Right?
Yeah.
How did you check that?
So we compared it with the iMac module, model.
Mm-hmm.
We compared the base case and the proposed case with the same, and then we found the number of comfort hours that are number of hours that are deviating from the iMac model case, and we added up the ones that are within that.
Got it. I got it. So you use simulation there? Did
Yes.
you?
Yes.
Okay. So that's what my question was. Did you use
Okay.
simulation in order to find out the indoor operative temperature?
Yeah.
Okay.
Yeah, well on time. Thank you, jury members. Yeah, if you want to, yeah, sure.
It's not a question, but just to let you know, guys, the business model that you guys looked into is very nice, and because to make projects like this possible, that's what actually more than the design and more than anything that we generally come up with, that's what developers look for. So and great job on actually working on the business model and proposing that.
Okay, sir.
Thank you, jury members. Thank you, team. Thank you, team, for your insightful presentation, and thank you, jury, for the comments. So we'll take a 5-minute break and then go with the second team, Team Daksh. So everybody settled? Our second presentation is from Team Daksh. They have worked on a project named Griha, located in Pathankot, Punjab. Please come by.
Hello, hello.
Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ping a bell like this. I will not give a 21st minute to you. I will stop you at the 20th minute, and then we can move out for the 10-minute Q&A session with the jury. You can start. The stage is yours. Thank you.
Good morning to the respected jury members and everyone in the audience present here. I am Ayushi Dwivedi. I am accompanied by Angad Singh and Sukhmanjot Singh. We are third-year architecture students from MBA School of Planning and Architecture, and we are members of Team Daksh, here to present our on-site construction worker project, Griha. The name Griha encapsulates the very essence of our project and its vision. Our mission is to create not just physical structures, but also thriving communities where construction workers find a sense of belonging. The word Sarthak in Sanskrit means successful, while Griha means housing or dwelling. Our team is composed of members of various backgrounds, ranging from architecture to civil, electrical, mechanical, and electronics and communication engineering. We are also guided by our faculty lead and advisors. Project Griha is for the construction workers working on the Shahpur Kandi Dam project in Pathankot, Punjab. It is undertaken by our project partner, Om Infra Limited. With a site area of 10,000 square meters, it is accessible by Madhapur Road, connected by National Highway 44. The site is within 5 to 6 kilometer distance to Madhapur village and Shahpur Kandi village, and it houses about 350 individuals. The current housing provided is a temporary shelter made from metal frames and GI sheets, housing 8 to 10 workers each. While the company provides basic facilities like septic tank washrooms and resting cots, challenges such as comfortable living spaces, WC maintenance, and management of solid waste still persist. Site constraints observed was noise from the construction site, dust due to the unpaved roads, no clear accessibility to the housing units, and remote location. Requirements outlined by the project partner for us for our proposal was minimum lifespan of the housing unit must be of 3 to 4 project cycles, affordable housing, self-sustaining labor colony, low maintenance cost, and low transportation cost. So in the context analysis, we deduced that about 92% of the workforce consisted of male workers, out of which 95% were skilled laborers. Since our proposal requires skill to put up the unit together, this was a benefit for us. And the rest, 8% were female unskilled laborers. 47% of the workforce were migrant workers, migrating from their homeland, which were mostly the northern states of India. And we also took into consideration the cultural background, since off-season for these workers depends upon this factor. And now coming on to the conception of our site, first we started with the unit design. The units were then placed into clusters, and the clusters were then placed onto the site according to the site constraints and community interaction requirement. So our design focuses on the concept of plug-in modules, which are arranged according to the scale of the workforce and the needs. Each unit is of size of 3.5 by 6.5 meters, and it is made from sagwan wood connected with steel cleats. The flooring is made from sugarcrete flooring, which will elaborate further, and the walls are made from straw bale panels, where the roofing is of Rycron. These modules are ideal given the temporary nature of the housing, and the need to avoid to leave any residue on the site after the construction work is done. Yeah, next coming on to the cluster design. Each cluster is made up of 16 plug-in modules. Throughout the site, 7 clusters are placed, and the first 4 units are connected with a central staircase and landing, and 2 clusters are connected with a connector, allowing easy accessibility to the upper floor units. And the top floor units have a sloped roof of 30-degree angle. The clusters are positioned according to the user accessibility, community interaction, and to prevent overcrowding. Green communal spaces are provided between the clusters to promote community interaction. Communal facilities such as mess, crèche, shop are provided, and they are provided near the entry for easy access. Designated parking is also provided near each cluster. This is a walkthrough of our proposal, which takes you between the interaction and the circulation spaces between the cluster, leading to a hierarchy of green spaces. The conception of these spaces is taken into consideration from a household level of interaction to a community level of interaction.
Now coming down to innovation, starting with flooring. After evaluating several flooring materials, including rammed earth and cob, our search led us to sugarcane baggies, a composite material that is affordable, eco-friendly, and can also serve as a passive cooling measure. Sugarcane mills produce a large amount of baggies, bringing down the cost to 3 rupees per square meter. Sugarcane has a low embodied carbon energy of negative 0.029 kg carbon equivalent and is fire resistant with fire rating of 60 minutes, making it suitable for various applications like load bearing walls, flooring, and roofing. Its demountable and reusable qualities make it a sustainable choice. Coming down to foundation, waste charges were observed during the site analysis, leading us to the idea of incorporating them into our foundation. Research supported this idea, showing us the evidence of tires' load-bearing capacity and other necessary criteria. Our team chooses recycled tire for foundation due to its local availability, lower cost, and ease of assembly. The tire foundation requires less time and manpower than concrete foundations, offer flexibility for relocation, and reduce the overall cost of the module. These are the drawings depicting our foundation, starting with a gravel bed, then a bed of PCC on which our tire foundation is resting. The tire foundation is filled with sand and gravel. Then over the foundation is a metal plate on which our steel ice section is placed, which is raising the plinth by 900 mm. On the ice section, our frame rests. This is the animation for the assembly process, starting with foundation, then ice section, frame resting on the ice section, sugar-clad flooring, Tricron panel for roofing, and straw bale for the walls. It is possible to change the unit size and scale according to the structure's requirement by using unit which can be repeated at a much larger scale. The upcoming projects will require the unit to be adaptable and scalable. We did the calculations which showed the vertical load on foundation is 17.65 ton per meter square. The total load foundation can bear is 60 ton per meter square. Load bearing capacity of soil is 45.8 ton per meter square as per IS code 4098. Unit weight of tire is 10.79 Newton per meter square. Unit weight of RCC is 25 kilonewton per meter square, and design load is 17.65 ton, making the structure safe.
In the energy performance index, the base case has been kept at 21.73 kilowatt hour per meter square per year, which is the current scenario. And the proposed case we achieved is 16.08 kilowatt hour per meter square per year. Therefore, there has been a 30% reduction in the energy performance index. The usage of energy efficient appliances helps us decrease the consumption by 35%. The proposed assembly U value, 90% lower than the base case, decreases the load by 80%. The annual consumption is 37,000 kilowatt hours. We use 65 half-cut solar panels, which generate approximately 38,000 of kilowatt hours of energy. Therefore, getting a surplus of 1800 kilowatt hours. The payback period for solar panels is 8 to 9 years. We annually generate 2.87 lakhs rupees and monthly save 23,000 rupees. This graph here explains the relation between the budget and the EPI achieved. If we increase the budget, we may get more surplus energy. This is the electrical layout. We have one central fan here which serves the top of the bunk beds, and two small wall mount fans which serve the lower side of the bunk bed. We have one tube light, and switches are besides the doors, and sockets for mobile charging. In the below single grid line diagram, we have 15 kilovolt inverter which delivers power to the entire main supply and subdivision with MCB installed. Our max power consumption during the day goes to 9.5 kilowatt to 12 kilowatt. This is the justification for proposed case energy calculations. The energy calculations for the baseline case has same working hours except the quantity increases in places. Since LED illuminates more area than the average CFL appliances, the wattages to increase since LED are more energy efficient than the CFL appliances. This is the workers' routine. This timeline explains the routine of the workers. In the water performance, using low flow water fixtures, we decrease the per capita demand by 30%. We plan to recycle 70% for various of grey water for various activities and meet 90% of potable water demand through rainwater harvesting. EcoSTP helps us treat grey water and black water for domestic purposes like flushing, washing, and irrigation. This is the plumbing plan. We have 4 PVC plumbing pipes of 100 mm dia. Tanks have been kept near the toilets along with the solar water heaters. This table signifies occupants' daily water usage with each activity. And this is the total effective catchment area, which is approximate 5,000 square meter, adding the roof surfaces, the hardscape plants, and the softscape plants.
Now coming to affordability, the proposed design case is lower than the base case, the current case, by 4.9%, achieved by substituting the steel sections in the current case with wooden members. Collaboration with our industry partner providing us with STP and biogas plant is crucial, especially for MEP services. Additionally, the incorporation of straw bale panel and sugar peat has also significantly contributed in cost reduction. The payback period for the biogas plant is 1 to 2 years, and for Eco STP it's 2 to 3 years. This table signifies the detailed breakdown of the project. In the current case, the civil works takes around 60% of the total cost of the project. Internal work 16.8, MEP services 13.6, equipment and furnishing 4.1, landscaping 0.5, and contingency of 5%. But in our proposed case, civil works takes around similarly 59.82%. The internal works cost 9.28%. MEP services cost 20.84%. Equipment and furnishing 5.84%. Landscaping 4.1%. And contingency of 3.8%. In the base case, every 5 years, the GI sheets need to be replaced to sustain the dwelling unit. But in our proposed case, no replacement is required over 20 years. The replacement cost gradually increases in the current case due to the use of same material GI sheets throughout. But in our proposed case, we have used different material which brings down the replacement cost and distributed equally. These are the technical drawings of the unit design. The unit frame consists of 10 wooden beams connected to 6 wooden columns through L cleats and nails. The wall consists of 2 sandwich panels made up of straw bale panel and covered with NFC board. These sandwich panels create a cavity wall of 80 mm in the walls. The sugarcrete flooring is connected to the plinth beam through reinforcement running throughout the flooring and through wooden sections. These are the details highlighting the drawing of cluster and washroom layout. This table signifies the disruption caused by hazards and the design strategies we have applied for it. Considering the case of flooding, we have raised the plinth by 900 mm from the ground level, and we have used tires, which is naturally a water resistant material. For the case of fire, we have used epoxy resin on the flooring and the wall panels. We have provided exit for 32 vehicles for easy means of access, and provision of fire extinguisher and sand buckets near every exit point. For earthquake, to tackle earthquake, we have used frame structures, and the module can be reconstructed within 12 hours of the disruption. For diseases, we have provided means of potable water, and open spaces can be utilized as isolation wards as well. For heat wave, we have provided provision of green spaces between the cluster and also inclusion of cavity pots. These two plans signify the fire layout, fire evacuation plan. One staircase, as we can see, is provided for 32 people. Fire extinguisher and sand buckets near every exit points, and sandwich panel made up of straw bale and NFC are covered with resin, which increases the fire rating from 60 to 120 minutes of the material.
In case of disruption of water source, critical consumption would be 2887 liters per day, which would this achieves an autonomy of 8 days. In case of disruption of food supply, provisions of organic farming and collaboration with local farmers can help sustain the labor colony. In case of energy, we achieve 100 hours of autonomy with 7 batteries of capacity of 60 kilowatt hours. The dry waste like single-use plastic, sweep dust generated from the units will be collected and segregated at the source, which will be further collected by the local municipal authority. For the organic waste like seeds and kitchen peels, they will be sorted in the kitchen and sent to the biogas plant along with the landscaping wastes. These are the technical drawings of the Eco STP, which is provided by the industry partner. This will be installed underground in the services part. The biogas plant, which generates 7 cubic meters of PNG per day. The expected consumption is 14 cubic meters of PNG per day. Therefore, we need 0.5 LPG cylinders per day, and the rest will be taken from the plant. 350 individuals generate 175 kg of waste per day, and additional landscaping waste of 25 kg per day is generated, which is sent to the biogas plant. And the biogas plant in return generates liquid manure of 100 to 200 liquid liters per day, which is sent to the organic farming. Energy and thermal analysis helps us find that south facades received most solar radiation, followed by the east and the west facades. WWR has been modified, reducing indoor heat, and site landscaping also works as a shading device. Since roofs are most radiated, they are an ideal location for the PV panels. And the daylight analysis assured us that each unit in the cluster received daylight by applying 30% of the wall window ratio. The wind analysis shows us the cross ventilation, where the winds enter through the northwest side and exit through the southeast side. Max pressures are formed at the northwest direction, hence more openings are kept at the northwest side. In mental well-being, we promote a balanced work life by allowing rest periods, setting up peer support networks to reduce isolation, and encouraging an open communication between the workers and the management.
Now coming on to reduction in carbon emission. Materials with carbon negative footprint have been procured from regions near the site, resulting not only in diminished material emission, but also reduction in transport related emission when compared to the base case. Also, the steel sections used in our proposal are made from 59% recycled steel, exhibiting a reduction of 70%. Our principle was to attain carbon neutral edifice, encompassing all the aspects such as construction, maintenance, and transportation, and we have achieved a reduction of 71.8%. For the value proposition, we have taken into consideration 3 points of views who will be benefited from our proposal. First are the investors, the project partner. Second are the workers. And third, from a community enhancement point of view. For the investors, the housing solutions are designed to be highly cost effective, offering affordable accommodation without compromising with the conditions of living. And the modules have a lifespan of 15 to 20 years. It is a cost effective alternative as compared to the currently provided GI sheet housing. And for the construction workers, a conducive environment have been provided, leading to better productivity on the construction site, secure housing and clean water sanitation, food security through the means of organic farming and communal environment. And through community enhancement point of view, purchasing crop byproducts such as sugarcane bagasse prevents incineration and supports income. Incorporating of discarded materials such as recycled tires minimizes waste, and food supply supports local vendors. Thank you. And for our last statement, we would like to say through our design, we hope to provide a better living solution to these unsung heroes. And thank you for the opportunity for presenting our design.
Thank you, team. Now I'll move to the jury members for their comments. I will start with Monish.
Congratulations, team. It's a very good presentation. You said something about the cost of the flooring per square meter to be some.
Yes,
what is it?
It's 3 rupees per square meter.
3 rupees per square meter.
Yes.
Are you sure about it?
Yes, sir. How much we got market survey we could get, that was rough costing we could get.
3 rupees per square
Per square
meter sounds very extremely off. And I only have one comment. I'll summarize. I mean, overall, like I said, amazing ideas. I love the materials that you used and all of it. The only red flag that I see, like I said, the overall presentation has been very thorough, is the cost. And the cost that you're saying will be 71% lesser than the base case, right?
No, sir.
That's carbon.
Cost is 4.9% reduction or similar 5%.
So the cost in your particular case, because you have wood against steel for the columns and also all the members that you said, and also the flooring, will be substantially higher. You just need to look into that numbers, but otherwise, good job.
Few things that I just wanted to ask. One is you mentioned somewhere that your use of sugarcrete improves passive cooling. How?
मैम हमने जैसे प्लिंथ रेस किया हुआ है, तो जैसे एयर फ्लो होता है, तो अगर हमारा फॉर एग्जांपल गीला भी होता है, तो फ्लोरिंग हमारी ठंडी रहती है हमारी उसके लिए.
अच्छा.
तो हमारे के एयर मूवमेंट के लिए हेल्प भी करता है वो.
Air movement. What happens on the first floor then?
So,
first floor maybe you will use the same thing, right? So it has to do something with the property of the material itself, or what?
Ma'am, in this also we have
You
provided
have
this.
And sugarcrete being porous.
Sorry, sir. Thickness is 50 mm slab.
50 mm slab, so there is a gap, so there is a ventilated. Is it ventilated, that cavity?
Yes, ma'am, it's open.
On the sides?
Yes.
Then you will also have to see in terms of protecting it from pests and insects, and because sugarcrete again is an organic material.
Okay.
Anyway, those things are there. Okay, I just wanted to understand how sugarcrete, improves your passive cooling. Also, organic material गीला हो जाता है, in the sense that you are assuming quite a few things, that अगर गीला हो गया तो भी kind, तो गीला हो गया, it also has to dry out.
Yes.
Otherwise, it, future में it won't work out. Okay, it will get bad quite fast. Your wall panel section in the report also, it was not very clear to me, and even now I'm not very clear about it. That how is that section being done? Can you just show that?
Yes.
I'm not very sure.
Ma'am, in this we have a compressed straw bale panel. It is covered with NFC boards. In outside, this is one sandwich panel. Similarly, in inner part, and the cavity in this is between of 80 mm.
So basically, how thick is your straw bale panel?
Ma'am, straw bale is 70 mm.
70 mm. NFC is just a layer. That is, so 70 mm, 70 mm. Beach mein 80 mm. So 150 plus 80, you are saying, right? Do you think the cavity was required? I mean, I'm just asking, you're using it for insulation purposes. You already have straw bale, okay? And again, I'm assuming that the straw bale panel is something which you're not getting. That was something that in your report also I saw, that you said that, okay, you'll be helping the farmers out. I think that's something that you guys wrote, that you'll be helping farmers by getting the wastage from the agricultural fee. So are you saying that you will make those straw bale panels on site, or is it going to be manufactured by somebody?
It's going to be manufactured.
Okay, it's going to be manufactured by somebody else. Now the thing is that maybe this is too much of a complication in terms of 2 panels and then air cavity. Just have a look, think about it, because you're using it for insulation. Do you need that 2 straw panels and air cavity? Straw bale itself will have smaller air pockets, and air pockets is what is giving you the insulation, right?
Ma'am, in where we went to the site,
yeah.
In winters we need also insulation. So the climate is composite. In winters it peaks, and in summers too. So for that purposes, we added extra layer of cavity wall and insulation.
Okay. U value again, kahin pe mention kiya hoga, just have this thing about the U value. I think that's it. One small this thing in one of your slides I saw. You said quantity and the wattage increases energy wale mein because you have used LED.
No.
Shouldn't it be?
It is in the we were justification for the baseline case. In the baseline case, there are CFL appliances. So the wattages increases, and in the proposed
Look at how
case,
you have written it. Okay, maybe
okay.
Because I thought you meant the other way around.
No, ma'am.
The way how you have written.
Okay.
I think you should go to that U values. पीछे.
Yes.
So air cavity.
Point 22 is way too low, I think, for wall. Roof may you can do this thing. 0.22 is way too low. You may, if the people in using them are not opening your windows, किसी भी कारण से, you have the real risk of overheating it in the summers. Just that. Okay, sorry. I'm sorry about it. Anyway, Neeraj, I think you can
Yeah,
go
so
on with your comments.
that's what,
That's it from my side.
just connecting, how did you arrive at U value? General, just conceptually answer. What's U value?
Sir, the basic calculations we did. First, we created this assembly, finalized this, added the U values, and created a sum. Sir, U value is the which every material has an one U value with risk. Sir, like a material.
So U is thermal conductance.
Yes, yes, sir.
How do you calculate that? So I'm asking, how do you calculate U value?
Sir, we have other team members which calculated in the energy.
Is there anybody in the
electrical
audience,
energy.
your team member
No,
who has
sir.
worked on
No,
this?
sir.
See, it's very important, how do you, whatever you are mentioning in a presentation, you should know how it is calculated. Because if you don't understand this concept, you are mentioning it, then...
No, we, sir, understand the concept that, but the calculations were calculated by
it's
the
not
energy.
visible. So what is U value, how it is calculated? So it's a thermal conductance.
Yes.
Which is a reciprocal of thermal resistance.
Yes, sir.
What is thermal resistance? It is the ratio of thickness of material and conductivity of the material.
Okay, sir.
Thermal conductivity of the material.
Yes,
and it's the thermal conductivity which is very different for each material.
Yes, sir.
So lower is the better.
Yes, sir. Yes.
So K value means thermal conductivity, lower is the better.
From the base case, it is 90% lower, and from the GI sheet.
The point which I was connecting the previous discussion and this discussion is, first thing, when we know how these values are to be used and then envelope needs to be designed, then you will be able to choose materials properly. See, just because I have to achieve some U value or there is some base case, so I have to show some improvement and I am using X, Y, Z which is available. Let's not have that approach. Rather than that, just decide, okay, this is how it is. This much increment I need to make, and based on that, what would be my approach then? Then automatically you will come to know what would be a better material, rather than just some fancy idea and then I will choose something. So
yes,
there has to be logic behind madness. So innovation's good, we loved it. Use of those sugar crate or tire based your foundation, yes, very nice, very novel approach. But then see, for every madness there has to be some logic which was missing, because this is very important. And I think in your report the distances from where your material is sourced, so from where you have sourced this sugar crate?
Sir, it is available in the locally market. We did market analysis in the Pathankot, and they said that that bagasse is of waste for them.
And that's the reason I requested this analysis, because the thermal values for sugar crate, which is mentioned, which is an organic material. So I want you to be very sure, because what happens if you just source it from a market, you will not have any technical data, thermal conductivity, which has to be lower, U value has to be lower, R value, resistance has to be more, So these aspects you will not have it if you just source locally, number one. And whether those distances are accounted for in your carbon embodied calculations.
Yes,
so if you have, it's good because it's locally sourced. All right. So that's one thing. What I loved is, I'll take 50 seconds more. Okay. So which is very nice. I think this is also the comment for bamboo thing. I asked about fire resistance, and they have addressed it. See how you made a mention about epoxy. So epoxy is a chemical which has got wonderful fire resistance. So out of the flooring chemicals, if you see, it's a thermoset resin which has got excellent fire retardancy properties. So you have made a mention, so very good. We loved it because that's the way your sugarcrete fire resistance can be improved. Otherwise, there are a lot of concerns about use of organic material. About madam has mentioned few. Fire is one of the big concern. So you have addressed it, which is a good thing. What's the duration of project?
So it started. It's about 10 years, but now it has just recently finished. They are just finishing the last powerhouse now, currently.
Okay, so now. Project duration is 10 years.
Yes.
Okay. Okay, thank you.
Thank you. Thank you so much.
Good presentation.
So thank you, jury members. Thank you, Team Daksh. It was a good presentation to have some innovative design and innovative materials being used. So now we will have a 15-minute break, tea break. After that, we will resume with the third presentation. The tea is available just outside the hall. So let's break for tea and then we can join back. People online, please be tuned. So let's support the teams coming by. Thank you. So welcome back after the tea. Welcome back to the Construction Worker Housing Division. We will now continue with the third presentation. Our next team is Team Eco Orb. They have done a project named Maitri, located in Karaikal, Puducherry. Please be. Yeah, ready team? So you will have 20 minutes for your presentation to the jury. At 15 minutes, I will ring a bell like this. Okay. I will not give a 21st minute to you. I will stop you at 20 minutes with maybe 2 bells. And after that, we will have a 10-minute jury comments. Post that we can do. So, are you ready? You can start your presentation. Your stage is yours. Thank you.
Honorable jury members and audience, good morning to you all. We know that exponential growth in the construction industry have attracted a large number of workers into this industry. Construction workers often move from one site to another, forcing them to put up with temporary living conditions. Our project Maitri is an attempt to address the on-site living conditions of construction workers in Karaikal, where we provide a holistic solution for the upliftment of their overall well-being. We, our Team Eco Orb, a group of multidisciplinary students, 15 members from National Institute of Technology, Tiruchirappalli. We have partnered with NIT Puducherry to construct, design and propose our on-site housing for 240 workers at their campus. Our industry partners are Recron Panels and Solar Green Technology. The special requirements from our project partner were occupancy of the project, cost effectiveness of the project, ease of installation and dismantling, and little or no construction waste.
So the description of the site is located on the NIT Puducherry, which already having several ongoing constructions, for example, indoor and outdoor stadium, quarters, hostels, etc. So we have visited the site and we have observed and interviewed that there are many challenges which we have observed, like water scarcity, inadequate drainage, unhygienic toilets, lack of essential active services, security issues, no recreational area were there, insufficient storage in the modules were there, poor ventilation and inadequate waste management was there. So we have, as per the context analysis of the Karaikal, we have observed the regional materials, out of which we have used bamboo, thatch roof and reclaimed wood for our project. And as per the environmental challenges, flood and cyclones are the major concern in the Karaikal. So as per the climate analysis of the Karaikal, we have observed the average yearly temperature is 28.7 degrees centigrade and average humidity is 77.6, where the predominant wind direction is from northeast to the southward direction. So the passive strategies and human-centric strategies are few concepts which we have followed in our design. And while moving on the design, we have did the radiation analysis for single modules and we have observed which position is the best. So option 5 here we took for our design. So as per the evaluation of the design, we have considered 2 different modules. First is the 3 by 3 meter and the second one is the 3 by 6 meter. And each module can be horizontally assembled and can be vertically up to G+1. So while moving to the design development, we have done the several iterations based on the wind flow, based on the shadow analysis, based on the cost estimate, affordability. So we have come up, or considering all the factors, we have come up with the iteration 5 going for the art design as the best consideration. So moving on the site plan, we have the site is like 4,725 square meter, where the ground coverage is 22% and we have considered the total FAR achieved is 0.29 for our site, where the permissible FAR is 0.9. So that we have provided the two separate entries. So we have segregated 30 family units from the left side and 30 bachelor units from the right side. So we have bachelor units are G+1 and the family units are single story. We have also proposed the common kitchen with the dining area, two different dining areas, which can be act as a multi-purpose spaces. We have also placed as a separate toilet for the family and the bachelors, where we have provided the sedimentation tank, water, laundry area, and all the necessary spaces behind the site. And also we have proposed the healthcare unit at the main entrance, creche area, library, office area, and for the security we have proposed the CCTV camera and for the security office. So this is our circulation plan, where we can see that easily every space can be easily accessible from the each spaces, ensuring the privacy of the occupant while moving from one place to the another. So while giving to the user experience, we can see the pocket spaces which we have provided in our site are facilitating our communal activities, which in result enhances our resilient engagement. So basically, these are the overall site where we have proposed the communal spaces. They can promote a sense of belonging to in the site for the occupants, and which encourage the collaboration, and which in result enhancing the well-being of the residents over there. So the material selection for a project is basically considered while considering the thermal comfort of the occupants, and we have chosen the Decathlon panel for the wall assembly and for the floor and roof assembly, and puff panel also we have considered for the roof. And for the insulation, we have used the quiet insulation with the bamboo framing to stitch for the connect with the Decathlon panels. And we have achieved the ECBC standards. As per the ECBC standards, for a warm and humid climate, we have reached the U value for the floor, wall and the roof. So these are the typical architectural drawing of the 3x3 module, the plan and section. The wall thickness is 100 mm, we have reached, and this is a typical architectural drawing of the 3x6 modules and the sections behind that. This is a plan we are showing how the bachelor units are placed from one above the another, which enhances the mutual shading and also which promotes the wind flow of the bachelor units.
Here we have considered lightweight steel sections, but in case of columns, we have considered ISHB 200. These sections we have specifically considered to cater to G+1 modularity of the structure. In case where there is scarcity of land, there we can have G, but where there is G+1, where there is abundance of land, where we can have single flow. So while constructing or calculating the design load capacity of the structure, we have considered G+1, and every module, even if it's single story, we have considered G+1. Going back in the engineering and operations, we have considered the windows for as with reclaimed wood. These are louvers. When opened up to 50%, gives 50% thermal height comfort. Now the solid waste management, we have segregated it into inorganic and organic waste. The organic waste is compost pit, which is collected and kept at the site, which can be later on used as a fertilizer, whereas the inorganic waste goes back to the disposal unit of the NIT Caracal. We've also included PV panels at the site, which gives abundant electricity supply, and also water storage tanks from 5,000 liters to 1,500 liters. Now we talk about the toilets that we have considered is the eco sand toilets, which have their own soak pits, which later turns into a manure for the fertilizers. Talking about the kit of parts, here there are 4 kits we can consider. There is joint based, panel based, model based, and deployable construction material. Here the joining that we have considered is bolted connections. Therefore, it is easy to join and remove. But in case of the flooring and roofing, we have considered welded connections. The panel based connections are basically the panels which will go for the flooring, roofing, walls, and the modules. The modules are basically considered 3x3, 3x6, which can go one on top of the other, as well as they can be single story. The linear element, planar element are basically the connections that we are talking about and the modularity of the structure. Now in the kit of parts, we have considered the foundation to be made up of M40 grade concrete cubes, which will be 1 feet above the ground, and steel sections, then flooring, and which will be connected to the recron panels.
Considering the indoor thermal comfort and the well-being of the occupants, we followed few design and planning strategies. We have oriented our modules in the north-south orientation. As well, the bachelor units are stacked one above other, mutually shading each other. And we have cross-ventilated each module, as well as these modules are insulated with the recroinant coir. And we have used reflective puff panels for the roof. And we have used the parametric windows with louvers. These parametric windows with louvers are chosen after seeing their advantages in the daylight analysis. These parametric windows louvers achieve about 82% of UDI when they are partially open, which is more than the requirement, ECBC requirement of 50%. And then we have considered the ECBC and ECONIVA standards for the WWR and WFR ratios, which are respectively 32% and 16%. And then we have achieved the comfort hours in the bachelor units to be 47%, whereas the total comfort hours per the year are 5,840 hours, considering the occupancy schedule of the workers. Given the energy, we have made comparison between the base case and our proposed case. In the base case, the energy consumption, total energy consumption per year is around 35,800 kilowatt per hour per year, with an built-up area of 900 meters square, and the EPI is 38 for the base case. Whereas in our proposed case, we have achieved it to be under 34,000 kilowatt per hour per year, with an EPI of 25. We have achieved it with the usage of cross ventilation and the insulation, as well as the manual shading, mutual shading. And then we have used the solar panels for energy generation, for the total energy generation, to make it a net zero building. So the solar panels, 68 solar modules are considered. 68 solar modules are considered, which produce about 34,000 kilowatt per hour per year, which is our energy requirement. So this satisfies our energy requirement, making it a net zero building. However, we can see the cost analysis of the solar panels. So the initial cost is high. So the initial cost is 43 lakhs. We can the payback period is 4 years, within 4 years, and it has a cycle of 6 cycles, which is around 18 years. And then so we can get back. So we can save 90% of our energy cost and 90% of our electricity cost over its life cycle. And for the water performance, as we can see, the only source of water for our site is from the municipal tanks. But there is a good potential for rainwater harvesting. So we considered the rainwater harvesting to make our design net zero water design. So as we can see, the total water consumption is 78 lakhs 80,000 liter per year, and we have achieved the replenishing the water as 92,000. We have replenished through the rainwater harvesting pits and the grey water treatment, along with the usage of our dry compost toilets. For the calculation for the rainwater is considering this Karaikal, it has an average rainfall of 500 mm in the peak months, and then the IGBC standard of harvesting at least 6% of this 6% of at least in the average peak months. We have made about three rainwater tanks, the capacity of 86.3 cubic meters. So this stores about 55 lakhs of water, and then the grey water treatment gives us a back of treated water, which is about 33 lakhs. So this whole value coincides with the requirement, which is the requirement is 75 lakhs, whereas the replenishing water in lakhs. We are getting a surplus amount of water, which the treated water can be given to the irrigation in the campus.
Coming on to embodied carbon, as you can see, the proposed case embodied carbon is way higher than that of the base case. This is because of the additional number of modules that we have provided compared to the base case, and also we have provided added amenities like creche, multi-purpose hall, etc. So the more materials and structural support, the more embodied carbon it will give in the initial case. Also, the materials have in total, in proposed case, will have a higher emission factor than that in the base case. In base case, they have used conventional GI sheets, which is usually dismantled and sent to scrap after one cycle of use. So considering one cycle as an average of 3 years, we have considered our life cycle of the entire project to be minimum of 6 cycles. So we did a comparison of 6 cycles. Here you can see over 6 cycles, the carbon emission for base case is way higher than that of the proposed case. This is because of the highly durable and sustainable materials that we have used in a project as Ricron panels and bamboo, etc.
Now we talk about the resilience of the structure. The structure has been designed by using StatPro analysis. And we have considered all the major loading forces, the self-weight, the dead loads, as well as the wind forces, which are predominant in the Puducherry area, which is highest in India, which is 50 meters per second. The loading capacity and everything has been done with the help of StatPro analysis. At the same time, we have considered in Karaikal, we have considered solar power systems, which ensures continuous backup to the entire property. When you talk about the vulnerability, we have compared the existing case with the proposed structures. I'll specifically speak about the major components. Structural damage to the existing case is very high. It's majorly made up of square steel sections as well as GI sheets, whereas the proposed model that we have ensured is giving very low damage to the structural capacity.
Now, coming on to affordability, as I mentioned in the case of embodied carbon, here also we have analyzed our proposal based on its life cycle. So even though the initial cost might seem a bit higher due to the materials and number of modules that we are going to use, throughout 6 cycles, that is the minimum life cycle we are considering, throughout 6 cycles, 18 years, the base case will cost up to 18.18 million Indian rupees, whereas our proposal costs up to 16.99 million Indian rupees. And also, by the use of renewable energy efficient fixtures, etc., we also managed to achieve an OPEX of 0.01 million only annually, whereas the base case it is 3.4 lakhs annually. Now, Maitri is not just any housing project. As you have already seen, we tried to transform construction worker housing with modular solutions, which is, of course, modular, extensible, scalable, and reconfigurable, where we provide a holistic approach for the enhancement of productivity and well-being of these people on any site. So the kit of parts technology is the main feature of our project, where we can actually disassemble and assemble, move this project from one side to another side without any hassle. Also, this technology or this approach helps us to leave little waste at the site once moved. In the race of being modular and movable, we never compromised on user comfort. We managed to achieve a total comfort hour of 37.07% compared to the base case. By providing amenities and proper standard area requirements, we tried to increase the quality of life, which will in turn help the company to have an enhanced labor retention as well. So to conclude, this project is not just any housing. We tried in the last 9 months. We tried to make the construction workers feel they're at home, away from their home. So we, myself, Sana, Abhijit, Abba, and Sandeep would like to thank the SDI team and the audience for giving this opportunity to present our project. Thank you.
Thank you, team. You did a good job. Now let's move on to the jury. Yeah. I'll start with Nilesh.
Hello. Yeah. So, what's the innovative element in your project?
So we would like to say it is the ease of assembly and disassembly, ease of movement from one side to another, with all the structural systems and material compositions that we have used. The kit of parts technology is what we consider as the innovative part of our project.
Okay. So you have used Recron, you have used puff panel, and you have also showed some embodied carbon calculations. So how you could have done differently to reduce it? Because you specifically said because of so and so reason it is increased.
Yes, sir.
What you could have done better?
No, sir. Like we did not consider it for one cycle. We consider it for the minimum life cycle of the entire project.
What's the duration of project?
The project, as in, so the contract has now been given for 2 years, which is highly high. There are high chances that it will be extended till 10 years because that this campus is the one of the newest NIT campuses in India. So there are like multiple ongoing projects also.
So these 3 cycles.
Yes.
So 10 years, 3 cycle you are saying?
No, sir. 3 years. We consider one life cycle. Project
Right.
cycle is
So
3
3
years.
years, 1 cycle.
Yes, sir.
Fine. See what happens when you have material selection like this, which is going to increase at first place, which is going to increase your embodied carbon. That's not something desirable at this platform, because our attempt should be to reduce it. That's number one. And this can also be done by choosing your materials very smartly. Coming back to the cost part, you have used puff panels. See, good. So I'm not commenting, but then issue is, you see, look at the cost numbers. What's the cost of puff panel? What's the thickness you have considered? Puff.
So thickness is 30 mm, sir. Puff.
Are you sure it's 30 mm?
Yes, sir. 30 mm.
Okay. And what's the Recron thickness?
So Recron thickness in the roofs, we have used 3 different thicknesses. Outside exterior 8 mm and inside the Recron is 5 mm and for the floor Recron is 12 mm.
Okay. So 30 mm of puff sheet.
Yes.
You see, it's typically puff sheets is, that is contributing to your cost number, and it is also contributing to your embodied carbon calculation heavily. So you could have actually done it very differently to reduce it. So that's one specific comment. Then for 8 mm, I think you are mentioning in your report U value of 0.27.
Yes, sir.
You need to revisit. Do you have documentary evidence, data sheet by a manufacturer? Are you
yes,
sure about
yes,
this number?
Recron panels are shared as a report. There they have mentioned the conductivity of the material.
What is that?
So 0.5.
0.5 watt unit?
Units are conductivity.
So it's generally
yeah.
watt per meter Kelvin?
Yeah, yes, sir.
Okay.
Yes, sir.
0.5.
Yes, sir.
Okay. 8 mm.
Yes, sir.
All right.
Hello. Monish, you can go next.
Yeah. Hey guys, good job. You guys have done very well with the structure, your water, and on the architectural design as well as the overall the master planning that is there. You guys have done a really good job there. But one thing that really catches the attention is that you mentioned that the ground coverage is 22%.
Yes, sir.
And even for any commercial project of any other nature, whether it's housing or not, that's too low. And why that is really important is because in projects like this, for developers, when you're talking about it, such a density is a luxury in places. And especially if you're saying that your land is going to be locked for 10 years, which is what you're saying, and the density also impacts the affordability and the overall feasibility of the project. So I personally felt that probably the density could have been better. And whereas in this entire, what is the site area?
So site area is 4,725 square meter.
So you are accommodating 240
240 workers, out of which 180 are bachelors and 30 families were there.
So this 240 is the
existing sites are construction workers over there.
Considering that, and this is the number given by your project partner?
Project partner, yes, sir.
Okay. So maybe, considering that because it's 10 years and all of that, probably had you considered more people within the same land parcel, would have made it better. And
actually, sir, in that site, two different contractors were working. So this number is exactly given by the SOM projects. So they were dealing the SOM projects. They were handling the 240 workers existing sites.
Yeah, probably could have made it more denser, left it more land parcel for some other purpose in the future or something could have been also considered.
Yes,
and the structure is very understandable because you did mention you had a valid reason behind the design of the structure with the cyclones and the storms in Pondicherry. So that justifies the design what you had considered, and also it shows the increase in the cost and also in the embodied energy. But definitely on the overall materials, like Nilesh, I totally align with Nilesh on the embodied carbon print. You could have considered other options as well.
Hi. I won't repeat the things. Obviously, those were the more glaring things because the aim was reduce embodied carbon. So, reduce embodied carbon. Though you also mentioned in the embodied carbon said that you also gave certain other facilities or something. Maybe you gave other facilities. So, in that case, would it have helped if base case embodied carbon number divided by the built up area? And proposed case, because you must have increased the built-up area if you gave certain extra facilities, right? In that case, then the proposed case embodied carbon number divided by the built-up area. That number, just like EPI, no? EPI you see per meter square. You could have seen it. I'm not very sure if it would have reduced or not because you are using puff panel, which is high embodied this thing. And I also see that you had mosquito nets and also these are good facilities, like having them. So the justification, you could have looked at it in a different way rather than just the absolute number. Probably that is one for embodied carbon. Then for your thermal comfort and all of that, I mean, even in your report, I was a little confused in these things. Right now, somewhere you have mentioned minimum temperature 28 degrees Celsius, maximum temperature 49 degrees Celsius, average 35. What is that? I did not understand that. Is that the thermal comfort range that you are aiming for, or is that what happens there?
Ma'am, the thermal comfort range, we have get the values from the IMEC for the Chennai temperature because Caracal EPW file was not available. So we did the average of the temperature, minimum temperature, that is 26 and the maximum is 30.
This is probably UTCI, right?
Yes, ma'am, UTCI.
Okay, so see, it kind of in this slide, it kind of doesn't make sense. You see, there is a daylight thing, UTCI, where did it come from? So it's a little confusing, just saying that. Then about the energy consumption numbers, I won't talk about it right now because that is something which I felt is there in all the groups. So I would rather address it at the end of all the presentations, probably, the EPI numbers and all of that. Though what I will have to say, in the presentation, it did not come out very clearly, but in your report you had the calculation numbers for WWR and WFROP, which I think are incorrect.
Ma'am, actually we have referred the Econivas standard and also we have referred one is research paper that did the natural ventilation daylighting and in that research paper they have recommended
the recommendation is another thing. I understand what the recommendation is, but how you in order to see whether you have achieved the recommendation or not, you must have done some calculation, carpet area, openable area and all of that. I'm not very sure if those are correct. I can talk to you about it later. Okay. But that is what I'm saying, that the WWR and WFROP, because those are the things that you're mentioning in terms of your thermal comfort thing, right? So just be careful about that. That's all I think.
Ma'am, ma'am, just 16% the Econivas, we have considered a standard that is recommended in the Econivas Sanstha that for women event.
Yeah.
So we calculated WFR as per that.
Yes.
And we have cross-checked with that research paper that is coming less than 50%. So that's how we.
So as I said, the standard is not the problem. The problem is not the standard.
32.
I'm not very sure that how you reach that 16%, whether the denominator and the numerator that you have taken is correct or not, based on the table that you have given in the report. Okay, you may have done it correctly, but from the report it is not evident. That is okay.
So, thank you, team. Thank you, team. Thank you, jury members, for the insightful comments. And hopefully, they will also work on the comments given. So, we will take a 5-minute break until we start with the next presentation. Back, people. Now we'll go with our fourth presentation. Our team is Team Samarthan. They have done a project named Native, located in Mumbai, Maharashtra. Please come back. Ready? Yeah. So, as I've said for the other teams also, you will have 20 minutes to present to the jury. At 15 minutes, I will ring this bell, and at 20 minutes, you're done with your presentation. I will not give a 21st minute for the for you to go ahead. I will again at 20 minutes push this bell like this. Fine. After that, we will have a 10-minute Q&A session with the jury. You can start.
Good morning, Mananal present here. I, Gaurav Kankekar, along with Harsharaj Sankhe and Karthik Kumbar, we'll start with our presentation. So, have you ever thought whose unseen hands shape our economic skyline? Well, about 95% of India's trade by volume and 70% in terms of value is moved by sea. Dockyards plays an important role in boosting India's economy. Dockyard workers who diligently contribute to enhance trade and are the backbone of this sector. Yet they are live in heartbreaking conditions with no proper sanitation and desperate shortage of basic amenities. The dockyard carries more than just ships. It holds the hopes of a city. With every rivet hammered and every cargo loaded, it's not just business on the line, but the very pulse of Mumbai. Here is Team Samarthan, a multidisciplinary team focusing on the lives of dockyard construction workers, collaborated with our project partner Ratandeep Enterprises and VKE as industry partner under the guidance of our esteemed faculty members. With the aim of providing safe, affordable, convenient housing for the construction workers, Project Native is located in Darukhana Dockyard. It falls under warm and humid climate zone. The development site lies under safe zone from sea water level rise as per the current development plan and intergovernmental panel of climate change. The soil in the region exhibits distinct characteristics with a black and yellow marine clay overlays brownish soft clay with weathered rocks at the lower layer with a shape bearing capacity of 50 to 75 kilopascals. Existing surface temperature observed is 28 degrees Celsius. Wind predominantly flows from southwest to northeast during day and from northeast to southwest during nights. Region experiences a temperature from 20 degrees Celsius to 34 degrees Celsius with a maximum precipitation during June, July and August. A psychometric chart represents the comfort hours with help of different types of passive design strategies. The location lies in a region with high risk of sea level rise and storm surge. This presentation animation shows the water level rise. Issues faced by construction workers were identified to understand the need of the project before starting with the design process. The site location lies adjacent to the Masgaon Dockyard Shipbuilders Building and falls under well-connected network of roadways as well as local ways. Further, the team studied user profile and demographics of the site, where total population observed on site was 214 with 138 males and 57 females and other toddlers. While conducting interviews, the team observed several issues including delicate shades, unhygienic surroundings, unkept cooking, congestions, scaffold existence, hazardous childhood, water shortage, and unseen living. Few photographs taken while site visit. Later, the site stakeholders were identified to understand the implementation viability of the project. Later, user activity mapping of male worker, non-working females, and children was noted, and activity mapping adopting proposed design was prepared.
Total site area considered was 3,107 square meters. Oriented east-west along the east-west axis, the sun moves from the southeast to the southwest, which shades about 18% of the site throughout the year, and overall 40%, reducing the cooling load on the dwelling units. The farm development started with placing the required volume on the ground, adding accessways, cutting the volumes into 6 parts, adding perforations for ventilation and recreation, lifting the mast to self-shade the modules wherever required. This is the plan showing overall layout with entryways and exitways. A cluster section showing levels. Upon entering the site, one immediately notices the presence of family units along with a workshop space and a kids play area. Adjacent to the family units, there are female units followed by the male units, and at the center of the site there is a specific area for washrooms along with kitchen and dining facilities. Next, the walkthrough explains the position and volumes of design spaces in the site. When it comes to defining the design of a unit, every unit is of 4.5 meter by 3 meters of floor space and an additional 1.2 meters of lobby in the front. The section explains the architectural features like stack window and sloping roof profile. Arriving at the assembly of the module, the first step involves precise placement of a sturdy cylindrical footing anchored 500 mm deep into the ground, ensuring a stable foundation for the structure. With footing in place, the prefab structural frame transported to the site is erected steadily considering the component alignment, forming the skeletal outline of the system. The prefab structural frame is salvaged from the scrap generated at the site. The members are bolted in place and brought to the site where they are erected. Next, floor joists support the flooring assembly. The assembly consists of 3 layers. Fiber cement board provide a flooring surface on the inside, while the void between is insulated with straw bale insulation, and the recurrent sheets form the external envelope of the floor. Providing lateral enclosure, wall panels fit into the wall studs, leaving out the openings. This assembly is a sandwich panel composed of 2 plain recurrent sheets with cork insulation within. The assembly overall emits 109.74% less CO2 emissions, which makes it a carbon negative option with minus 3.2 tons of CO2 emissions of the entire project where this material is used. Doors and windows are then installed at the openings. Finally, the roofing assembly sits at the top of the structure, completing the envelope. Solar PV panels are then installed on top, harnessing renewable energy, contributing to the energy requirements of the site. Recurrent sheets, given its performance in heat and moisture, is given place at the topmost enclosure, followed by a 50 mm thick XPS foam sheet, below which a layer of gypsum panels at ceiling are installed. These are some details of different sections in the unit.
For optimized, strong and economic structural design, we have used ISMB 1200 as primary, ISMB 150 as a secondary beams, whereas ISHB 200 as a columns, and angle sections for bracings. The structural analysis has been carried out in StatPro and the overall structure is safe and stable. Coming to the innovations, we innovated a micro energy generator which has a simple assembly of that harnesses tidal energy with up and down oscillation of the copper coil inside the envelope of magnetic bars that can generate the micro energy with every oscillation. Considering optimum number of waves, we can generate around 7.2 kilowatt hours of energy with 2 ohms of resistance and 0.5 meter long 1 Tesla magnetic field strength. It requires a circular coil with approximately 20 turns and length of approximately 0.3 meters. If the coil oscillates 10 times every minute and for 12 hours a day, generates 7.2 kilowatt hours of energy.
When we think about a water tank, a cylindrical or cuboidal structure pops into our minds. But for the proposed building, deployable water tank has been introduced, which can be customized as per available area, similar to Tetris pieces, which is expandable as it comes with removable walls made up of polyethylene and Velcro zippers. To check the feasibility, the problem was solved by numerical modeling in ANSYS. The calculated maximum stress acting on water tank with full water capacity was 0.07 megapascals, which is far less than its tensile strength ranging from 10 megapascals to 40 megapascals. This signifies the water tank is safe and is operable. Few more strategies incorporated were a dining table with seats made up of metal barrels. Its forms enable flexibility as well as it requires less space when not in use. Adjustable wooden slate bed. The beds are constructed using wooden slates offering durability and flexibility. It will be an effortless transformation from a bed to a recliner or a sofa according to the needs of the user. This multifunctional design maximizes the utility of limited space within the housing units. Solar bulbs. Taking inspiration from Alfredo Moser, a solar bottle bulb was introduced to utilize the sunlight during sun hours. Few more strategies used including the barrel foundation system using geocell as a base with filling aggregates in cells followed by PCC layer. The sand and concrete layer contained inside repurposed barrel, placing bolts during casting on concrete on sand layer in barrel followed by fixing base plate of 350 by 350 by 12 mm in the bolts and fixing IS column with it.
Considering calamities like water level rise in adjustable plinth can be utilized using vertical frame which will act as a guide for the superstructure to elevate. It will have manual locking system to resist structural failure. Superstructure will be separated yet connected with the foundation using bolted metal plates with the I section. It will be unbolted during water level rise and could be bolted again after the level drop. Service layouts were done. Electric layout explaining the positions of transformer, electrical room and connections with the modules and other spaces. With provision of a ceiling fan, a light bulb and a power strip for charging purposes will be provided for one unit. Plumbing layout explaining the overall water flow throughout the site. Moving on, energy performance. The EPI score achieved is about 22.09 kilowatt hours per meter square per year with using several passive design strategies, and here we can see the comparison between consumption and generation chart where it shows clearly that in every condition building performs net zero.
The following chart displays different envelope assemblies for different building components in the base case and the proposed case. The comparison is done on the basis of U value, that is the thermal transmittance, carbon emissions and the cost. Developing building materials with suitable heat and moisture resistance according to the climate of Mumbai is prioritized. Ricron corrugated sheets, fiber cement boards, XPS and cork insulation are some of the sustainable components that lower the carbon emissions by 109.74 for walls and 28% for roof. The water cycle diagram explains the flow of water right from collecting it from the municipality as well as rainwater that will be used to fulfill the daily water demand. 4,600 kiloliter of grey water is generated and is treated by STP with an efficiency of 90% and remaining with the reed bed system, from which 90% treated water, about 3,700 kiloliters, is reused for activities like cleaning, utensil wash and flushing, with 130 kiloliters of water for irrigation. The remaining 10% untreated 400 60 kiloliter water is sent to the biodigester. A reed bed system filtering the grey water suitable for the project. Biochar filtration used to efficiently treat rainwater, which can then be repurposed for domestic use like drinking, cooking and other activities. Sea breeze water capture system made up of 40 by 3 meter stainless steel or aluminum alloy mesh, which can collect up to 450 liters of water per day. Ultra low flow faucets allow 0.5 to 1.5 gallons of water per minute, reducing water usage from 40% to 70%. Smart meters biodigesters are also incorporated into the project. Total 5 recharge pits are provided in the site with the capacity of 160 cubic meter.
A net zero solution of water is achieved by proposed water saving measures, which aim to reduce demand by 41%, reaching 79.65 LPD through ultra low flow fixtures, grey water treatment, 3.2 million liters of rainwater harvesting, and up to 2.5 million liter of water is discharged to the ground, with 3.3 million liter water is surcharged the ground, giving a net positive water cycle with backup supply of water that can last up to 5 days in case of any calamity. Waste management. Toilet module can be assembled with simple tongue and groove joinery between vertical mild steel members and FRP wall panels, followed by Ricron panels as a roof, and later fixing other members like door, windows. The module can be placed individually or in combination depending upon the site requirement, making it scalable for the market. Reusability of the panel is 15 to 20 times. Different color bins will be provided on the site for classification of waste. Organic waste is generated at the site location and then picked up by the garbage trucks from the municipality. Some of the organic waste is locally composted to create quality manure for landscaping. Awareness initiatives could be held for further empowerment of the strategies proposed. Implementation of community kitchen to reduce kitchen waste.
Now let's take a look at GHG emissions of the project. The overall emissions are reduced by 33% compared to the base case. The roofing achieves a reduction of 29%, while the wall design is able to achieve a significant reduction of 109.74 over the base case. The structural system also aids in the same, reducing the emissions by 50%, whereas the flooring and fenestrations, while they add up to the emissions of the project, it's not as significant considering the overall reduction in emissions compared to the base case. This is an outcome of material selection where thermal comfort and durability is prioritized, unlike in the base case where bare minimum is provided. Comfortable incident radiation by orienting of the housing units to optimize solar exposure and minimize heat gain. Direct sun hours in the region were taken into account, while shading devices such as overhangs and louvers were provided. Proper daylighting with optimized WWR was provided, considering visual comfort and limiting excessive radiation. Solar bottle bulbs are installed wherever feasible. Indoor air quality and olfactory comfort was achieved through use of low VOC material, stack ventilation, cross ventilation, separate provision of toilets and kitchens. CFD simulation explaining the movements of wind throughout the site. In conclusion, we can observe that the building is performing better than the base case in all situations. In humid regions like Mumbai, providing indoor plants like weeping fig, snake plant, the peace lily can purify the air and regulate the humidity levels, increasing the comfort in often humid environments. Mangrove plantation provide endling seedlings with better growth rate and a higher survival rate once they are planted in the wild, provide safety from higher tides.
Walkthrough showing the overall life into the central plaza.
Due to climate change, Mumbai will witness a 25% increase in the sea level rise, which is about 500 mm. Facing sea level rise, the city receives an average of about 2.38 meters of rain annually, tackled using adjustable plinths. In our case, temperature raises the risk of dehydration as workers have to go through intense hard work in the summer daytime. Water resilience by efficient rainwater collection and management is done. Rainwater collection systems could collect a minimum of 30% stormwater. Air pollution is one of the causes in Mumbai for adverse effect on people's lives. For easy and fast construction process, manual will be provided to the construction workers with stepwise assembly process. Concluding the value proposition, easy to assemble, increased productivity, reuse of material, a net zero solution can be achieved.
For giving this opportunity to present our work.
Thank you, team. Thank you for your presentation. It was a very good presentation. Now let's move on to the jury members. I will start with Saswati.
Hi. So first things first, your at least when you started off with your architectural process and the engineering thing, very well explained, I have to say. It's very, very clear to us in terms of how you showed it in animation and everything. The main thing that I would want to kind of showcase, can you go to your slide on thermal comfort? On you had one slide on incident radiation you showed in between, something like that. Yeah, no, before this, is this the one? Yeah, the next one. Okay, so this portion, I'm not sure how did you get to this thing of whether the indoors were comfortable or not. Okay, because you write something comfortable incident radiation. What is comfortable incident radiation? If there is a comfortable incident radiation, there has to be some key, okay, this is the limit. This is what comfortable incident radiation is, right? Like if you have comfortable IMAC comfort temperature, so it says that, okay, between this degree Celsius and this much degree Celsius, a human being will be comfortable in this climate. That is how it is given. Comfortable incident radiation, I don't know of a range or a number here, and I'm not sure what you are meaning by this. Okay, so the whole, how are you evaluating your thermal comfort in your design? I'm not sure of that. That is the main thing. Principally I can understand, okay, you have done this or north south and shaded and all of that, but when you are kind of evaluating it with, I don't know, XYZ, your base case or some other iterations, there it is not evident. That is one. Okay, so that was my main thing, because that also impacts your how you are calculating or how you are making the narrative of your energy optimization, right? So that is there. One other small two small things, like you did a CFD analysis. Why did you do it? You said, okay, we did our CFD analysis, but why did you do it? Did you use that in your design in some way and all of that? So when you're presenting or when you're writing it in your report, that needs to be evident. Also because you may have done a lot of things, but you have very small little time to present something, to only present that which fits in your narrative or is going. And the last thing is the structural system reduction, embodied carbon. I think I mentioned it in your report. I think you have mentioned something on steel, the type of steel that you are going forward. Unless you are saying that this steel is recycled, please do not use a lower embodied carbon number for EAF steel, because right now you don't have enough numbers nationally to be able to say that BOF steel and EAF steel will be like very less. In principle, it should be, but unless we know what fuel is being used and how it is being used, you cannot say that. Okay, just those things. mean, I'm not really expecting here right now. We can talk about it later.
Yeah, time is going by, so Monish, you can.
Hey guys, very good presentation, and it's very nice to see you put in a lot of effort for the presentation to make it very easy for us to understand. I think that must be really appreciated. Now talking about the same thing on energy, like with the same diagram, you spoke about shading right in the beginning of the presentation, how you oriented the buildings and all that. So did you consider your solar panels when you're positioning them, and how the shading, and also you spoke about mutual shading. So first of all, actually that's a very good thing that you considered shading, and as the first means of passive design, your site conditions to do it. I really appreciate that. But have you used the same thing also to calculate how it affects the solar? No, that is great. I'm convinced with that. So I'm asking with this, did you check the shading for the solar? And one last question on the same thing. You spoke about, I mean, I really like the innovation ideas that you presented in the overall submission, but on the one of the comments I made earlier also, on the tidal energy factor that you said that you're able to generate, and there was a comparison which I said that you can, if you multiply it by 4 times of what you're doing right now, you can actually replace what you're doing with the solar. So
right.
is it?
So considering the site situations, maybe it will not work in some situations where there will be not much tides coming in. So even considering other sites project partner holds, it won't be workable there. So we proposed solar panels, and with a combination of both the strategies, we can achieve the net zero.
So I mean that's the question. So the ROI, and I mean you don't have to answer this. In general, just keep in mind, because when you speak about it's a good ideas, but you need to back it up with the feasibility, whether the tides are actually, whether you're going to consider that if you have enough of those. And but when you're saying that it's almost close to, if you just multiply 4 times of the tidal energy that you have, you can replace the solar in your case, right?
Yes.
So you need to back it up with ROI, and also like whether it's how feasible it is in your case. But good ideas overall.
Yeah. We studied the like tides levels and all throughout the year, comparing with it the solar radiation. So in monsoon months, it will eventually go farther than solar panels, but during non-monsoon months, it will create very less energy. So that's why we propose solar panels. Thank you.
Yeah, I think wonderful innovation strategies. At least you are thinking in that direction, so that's really admirable, and very good presentation in terms of pictorial representation, easy to understand, as Saswati said. So good, very good attempt. So that's one thing. Then in your report, what actually struck me is you have used the distances from the source in your embodied energy calculation. Am I right? Okay, then the distances what you have considered, I think you need to relook at it. These are the shopkeepers which you have mentioned. You need to consider it from the source. For example, let's say you are saying 5 kilometers from this particular thing, there is a shop saying some XYZ Steel Mart something. Okay, so see, that's a seller. You can't count that. If you have to really do calculations, so consider the distance from where it is produced.
Right.
So if you do that, probably it will be better. Number one. That's one thing. Go back to your previous slides where roof section is given. Roof section. Roof. Yeah. Yes. This one. This one. This one. This one. Ah. So that's the undulation. So XPS insulation with undulation. So if you are removing, see what happens. I'll tell you. You are proposing to cut the XPS insulation in the shape. That's what you are proposing here.
It's just the compressed shape of it. Like it's not cut into.
See, generally the product is available in a square shape. So when you are showing this, are you proposing that the XPS insulation is cut in this form? No. Okay, good. And show it as a square. Why? I'll tell you. If you try and cut this insulation, the cost of cutting is half of the cost of product. It can even as good as cost of product. So your cost of entire roofing assembly will then be much more, will be probably double than what you should have considered. So good that you are not considering, because cutting such a thing is very costly affair sometimes. It looks to be simple, but it's not. Second, if you have to really find insulation which should actually take a shape of valley and rose, then you should change the material selection. You should change the material which can actually take the shape of undulation. So that's that one thing which you should keep in mind. Good.
Rectilinear, had you made it more slopey towards the edges, it would have been more stable for the water. Otherwise, it can collapse. But the idea that you want to use a fabric instead of using a hard reinforced water tank is also like really good. The shape would have been more like a.
Yeah, actually, we thought of something which is like Tetris pieces, which can like take whichever like the available area within the site. About the materials, most of the materials we are taking from the dockyard itself, as Darukhana dockyards disassembles a lot of materials from ship, and that can be utilized in this. Yeah. Yes. Thank you. Yeah. Thank you so much for
Thank
the
you, team.
comments. Yeah.
Thank you, jury members. Thank you, team. We will now break for lunch. Post that, we will continue with our fifth presentation at 2:30. People online can tune back to our channel and continue to support the teams that are coming by. Thank you. Let's join after lunch. Hello everyone, good afternoon and welcome back to the Construction Worker Housing Division. We will now continue with the next presentation. Our fifth team is Team Satwa 3.0. They have worked on a project named Ashray located in New Delhi. Please come. Ready? So team, you will have 20 minutes to present the work to the in front of the jury. At 15 minutes, I will ring a bell like this. Okay. And after 20 minutes, I will again ring a bell like this. I will not give a 21st minute to you. At the 20th minute, I will stop you from your presentation and then we can go forward for the Q&A session for the next 10 minutes. Okay. Are you ready? We can start.
The success of a construction project doesn't rely on innovative materials or technology. It relies on the dedication of construction workers who shape our living environment. On behalf of Team Satwa 3.0, we are extremely honored to present in front of you Project Ashray, a home for those who build. Ashray is a collaborative effort of students of architecture and engineering from University School of Architecture and Planning, JGSIPU, New Delhi, and IIT Roorkee, respectively. Our faculty advisors and our project partner, Ahluwalia Contracts India Limited, have been a source of inspiration throughout the design process. In the construction world, Ahluwalia Construction India Limited is a big name. For over 50 years. They've been building one of the most important projects in India and overseas. The construction site is adjacent to the IGI airport, which employs 1,400 construction workers who work in 2 shifts of 8 hours daily. Their housing is located 8 kilometers away in Samalga village, New Delhi. The land has been leased for 3 years and the project involves migrant workers from West Bengal and Bihar aged between 18 to 50 years living in the composite climate of Delhi.
Bhartiya Realty Limited has been granted access by the Delhi International Airport Limited to develop 100 acres of land in Aerocity, New Delhi. This is the same view of the site. 100 acres of land is being developed. So the existing site consists of 1350 male workers that are housed in double-storied wall panel units where the structure member is the steel sections. And the most of the material we are trying to reuse it for this to not undermine the existing construction techniques. I would like to point out here that there's only provision for 700 workers, construction workers at the same time, since the workers are working in 2 shifts. So one bed is being shared by 2 workers. Yeah. And if we look at the existing site plan, it consists of 3 major blocks that have been oriented in a way that covers the majority of the site on the ground and leaves no open spaces. So, and it also makes some isolated areas that are being used as dump for the garbage dump. Like this, garbage dump. So, were the issues that we identified on site were like cramped living conditions and lack of natural light, absence of female toilet spaces, and minimal privacy for the families. The kitchen was provided, but it was unfit for use due to the fire hazard, and they were very fire hazard. And so we felt the need. So all of this compromises the health and well-being of the workers. So we felt the need for reconsidering and redesigning the worker units for these dwellers.
So, based on the current living conditions of the site, we felt the need to improvise on the strategies apart from attaining net zero in the various contests that we have. Then our main goal was basically to provide adequate living condition for all the 1400 workers on site. As my teammate mentioned, there are only provisions for 700 people on site, and beds are being shared by 2 people. 1 bed is being shared. So for this, stacking of the units have been done so that the units take up less of the area on the ground, and we have more of the open spaces, which would also incorporate the sense of gathering and collecting together in the workers. Our goal and our client's goal to incorporate family housing units also coincides. So this is the proposed site plan. The proposed built up is of 4,815 square meters, and the placement of blocks or the clusters have been done in such a way that, as you can see, we can get ample amount of courtyards in between. There are many green spaces, open spaces. Why these green spaces have been provided? First of all, the cramped living conditions, as we mentioned. Secondly, these green spaces help in reviving the groundwater recharge and providing better landscape opportunities at the site. Also, the courtyards have been provided, and they also help in maintaining the wind channel between the site so that better ventilation is possible. The access of placements of these individual clusters has been tried to be placed at the longitudinal axis facing the north-south orientation. The water tanks have been placed near the site, near the entrance of the site, so that the water tankers, who are our basic source of water supply in our site, they do not have to travel long distances, or we have not provided the whole site access to the water tankers. The services have been separated. Also, the biodigester plant has been placed near to the washrooms, and the toilets have been separated and placed near the boundaries so that there is less of plumbing services required, and also in order to separate that out from the existing clusters in order to maintain hygiene and other safety issues.
So this section here depicts the communal gathering spaces that we've been trying to provide on a block level, and the courtyards channel wind through these semi-open spaces that increase the porosity of our blocks, and we have tried to provide windows on opposite walls so that the cross breeze through the courtyards can be channeled through the units. In this section, we're trying to show how a family unit design is based around an introverted courtyard design so that the women and children feel safe and secure. And the form has been developed by designing a single unit and then staggering it so that interstitial spaces can be created for staircases and kitchen on every floor.
The design proposal involves 2 typologies that we have introduced, one being the dormitory that is visible on the screen right now, and the other being the family units.
Coming to the male worker housing unit, that are dormitories, these are the units that are of 5.4 meters by 3.6 meters that incorporate 12 construction workers, 6 bunk beds and storage units. There are 4 of these units on one floor, stacked one over the other, going 4 floors high. Therefore, one cluster has 16 units. And just like that, 112 units are placed on our site. That is, 7 clusters have been placed on site. All these clusters have been made from repurposed GI sheets, rock wool insulation, also cement, fiber cement based flooring, and along with that, linoleum flooring has been on the top of it. Moving on to the second typology, which is of family housing units. These are the family housing unit clusters. There are around 12 family units on site that have been placed, each of dimension 3.6 meters by 3.6 meters. These three, they are 12 units, and there are 2 clusters, 6 units per cluster, and they also have a concept of introverted courtyard that makes women and children feel safe and secure. These units have been made from structure board, and the flooring is again cement based fiber flooring. So moving on, it is now evident that we have a major focus on outdoor focused design. Our design is basically focused towards the courtyard and creating these spaces, and what it does is offers a sense of community. So to make this design a reality, we start now with the structure of the building.
So we have reused the structural steel that was available to us on site. And the structural stability analysis that was conducted on StatPro shows that our structure was stable under maximum absolute stress and nodal displacement. So the structure is stable under current conditions. But however, our site also lies in seismic zone 4, and our proposed design also stacks up to 4 floors. Therefore, we have proposed an alternate foundation that was analyzed for having a factor of safety of 2. So that brings us to our innovation. This foundation is called microcap foundation system. Okay. This utilizes a portable precast pile cap which is attached to the base of a column through L cleats and a bearing plate. And this sits on top of a solid SS rod that has, which acts as a pile, and it has a 50 mm jacketing on top of it which prevents it from corroding. So moving on to our next innovation. So one of the major problems, the direct incident solar radiation on the western facade has been a problem for thermal comfort in our design. So we have proposed a facade shading device using cement bags, and it works on the mechanism of a tilt blind. The benefits of this is it is lightweight, it is cost effective, and it has very low maintenance. The graphs and tables given below give us the baseline carbon emissions for different systems in our structure. So there is a 21% increase in our embodied carbon. But it is to be noted here that the base case materials have been reused and repurposed in the proposed case. Therefore, the materials that were reused, we have taken their emissions as 0%. While doing calculations for proposed case, the base case qualities were subtracted from the proposed case. So the graph only constitutes to that materials that were being used in the proposed case. So in the table beside it, you can see that the grand total emissions per functional unit for the base case was 9,640 kg CO2 equivalent, while for the proposed case, the grand total emissions per functional unit was 13,521. But it is to be noted that if we were to build this structure from scratch without reusing the materials that were already available to us on site, the embodied carbon levels would have reached 23,160 kg CO2 equivalent. So this is due to the significant increase in the size of our proposed case. There is a very significant increase in our wall and floor area, which amounts to almost 2.5 times of our base case.
The health and well-being has been looked upon in two ways, physically and psychologically. Physically, it can be further categorized as visual and thermal comfort. So for the individual worker units, we are achieving a mean lux of 1061, and in the family units, we have a lux of 405. Looking at the thermal comfort, we are achieving in both the cases an mean radiant temperature in the range of 22 to 25 degrees Celsius. Talking about the air exchange per hour, so in order to uphold the indoor air quality, 7.2 air exchanges per hour is for the individual worker units, and 4.8 is in the family units, considering the number of occupants and the floor height and the volume of space and the ventilation rate. So the airflow diagram has been shown here. Windows have been made using the polycarbonate sheets of 4 mm thickness, which have a U value of 2.4 watt per meter square Kelvin. Going to the so psychological well-being interactive spaces have been provided, play area for children for the mental well-being, and for Udo compared to all the spaces have been separated from the accommodation units.
The EPI proposal for the design is 17.17 kilowatt hour per square meter annually. There is a 59% EPI reduction from 47.8 kilowatt hour per square meter annually from our base case. However, from the EPI comparison of base case and proposed case, it is very evident that there is an increase in lighting load, cooling load. This is due to the catering to a higher population that we have taken up on the site. To reduce this energy demand, we have optimized our building envelope to U values of 1.5 watt per meter square Kelvin, achieved a WWR of 30% in north side, 18% in south side, 14% on east side and west to optimize for the maximum daylight availability, and innovated shading devices to reduce heat gain on the envelope. Our solar energy potential on site shows that we can produce 95,200 kilowatt hour per meter kilowatt hour of energy annually from 350 panels accommodated on site of wattage 450 watts.
Coming on to the water performance, the water source of water is our MCD water tankers that access our site. As we come to the water consumption, the base case consumption was 138.5 liters per person per day, and this has been significantly reduced to 60%, that is 61 liters per person per day, and this has been possible due to the involvement of our industry partner AKM Eco Solutions Private Limited, and they have provided us with aerated faucets, water dual flush tanks, low flow fixtures, and along with that our water recovery system has also helped in it. Coming on to the water recovery system, we have two types of water recovery system, one for grey water and one for black water. For grey water, EcoClean 20 has been added. It acts as a coagulation agent and settle down the sludge. And EcoClean 50 is added later on at the second stage, where it just disinfects the water and it provides us 90% of the grey water that is recovered. Coming to the black water technique of water recovery, we have EcoClean 2300. This cleans out the black water to 70%. We have a 70% recovery rate of black water.
The daily human waste generation on site is 478.5 kg daily, which produces around 20.44 meter cube of biogas per day. This results in a 15.7% reduction in LPG usage Additionally, up to 25% of the cement bags wastage that we have on site can be utilized to create the shading devices proposed.
The evacuation plan has been shown. Daylight electrical autonomy of 48 hours has been provided, and for water, 3 days has been provided. This is a different design strategies according to the natural calamities. Then a dedicated recovery plan has been devised here.
The cost comparison of base case and the proposed case indicate that there is an increase in the MEP cost because of lack of amenities in the existing base case. Then the LCC comparison shows that there is a significant drop in due to the decrease in OPEX in the long term. This is because our construction worker housing meets our energy demand through solar PV generation. Earlier, it was used to have 200 liters of diesel used by DG sets per day.
So Ashray devices enhances the living construction workers' conditions by we have significantly saved 59% energy. Water savings is 60%. 44% we have saved in the foundation of cost of foundation, and then we have achieved 100% energy through solar generation, and we have repurposed waste to innovate solutions. The structure board that has been used in the family units could have also been utilized in the construction units, but that would be done. We have given the air gaps. We can do one line. So, it could have been used in the family units as well if the existing material has been depleted. So, Project Ashray aims to enhance the living conditions of the workers by providing according to their needs, and that is how we have achieved our goal. Thank you.
Thank you, team. Good presentation, some good bit of work, though you had shoot off your time, so it's okay. Let's go to our jury for the comments. I will start with Monish.
Hey guys, good presentation. I have a couple of comments, one on the architecture design and the structure. So in terms of the design, what you tried doing is really nice because you identified the problem of how people sharing the beds and wanted to go about redefining the density. That's a very good idea to start with, and how you went about actually creating this the spaces. And the use of courtyards and green spaces also enhances the design for sure. But the question is, when you showed the structural analysis, I think you have done it for one unit. I'm not sure if you have done it for 4, stacking one on top of another, because that's not clearly evident in the presentation, how you managed to get this. And the second observation is that while in the whole process of trying to gain this, the density and the efficiency you spoke about, putting in 14 people in a room might not be 12. Yeah, 12 is also like still quite a lot. I mean, people in one room, and also the stacking and everything. I think that is something from a quality of space perspective you can look into it. And you also mentioned that from an energy perspective, it's 100% solar. Is it needed to make it 100% solar? Because ultimately it also has an impact on the overall project cost. And especially because the site is in Delhi and very close to IGI airport. So in Delhi, there are not shortage of electricity for sure, right? So why 100% solar?
It was in order to provide autonomy for more than one day. Like we tried to provide a 24-hour autonomy. That was the main goal. We could have provided 546 panels on the overall construction housing, but we chose to go for 350 panels as it completely fulfilled all our energy needs.
Yeah, I mean, I'm sure this does, but because there is also in Delhi there is barely a power shortage. So I just wanted to check if there is a need actually for that much solar power to make is one question, because ultimately it affects the investment of the project to the developer. They have to invest, the cost of the project increases. Ultimately, the affordability and the cost. And one last comment is also on the envelopes, both the structure and envelope. What are your thoughts? You haven't actually spoken too much about the envelope design, because the material, I think you're using the puff panels, right, for the structure?
We have reused the existing puff panels that were present on site. Those were present in the form of sheets. We have basically converted them into our own customized panel sizes, and we have designed our own panel joineries for that. Can you go to the next slide? Yeah, there is the joinery that is shown. It is similar to what existing puff panels have, but it has rubber gaskets on the edges to prevent waterproofing, and it basically utilizes the same existing materials. That was the main goal. Since our project partner already has these materials in abundance, our main material that we wanted to go for is structure. However, we were not able to use it for the whole project, since it would have shoot up the affordability to such a level that it wouldn't have been feasible at all. So we chose to go for the family housing. Since it was not present on site, they had plans to provide housing for that. So we chose to go for the structure board for the family units only.
Okay, got it. Thanks.
If I can add just one more thing. For the 12 since we have provided 12 bunk beds at a time, in the room there would be only 6 people, since half of the people are already on their shift. Earlier it was that one bed was being utilized by more than 2 people. So we have tried to avoid that, since there is a concern of health and well-being.
Also on the structure front, think about it, because if you've done the analysis, the structure will be much more what is requirement, affect the embodied carbon ultimately. So the structure what you have considered right now might be less for 4 stories that you have created.
We have actually ran simulations, structural analysis for all of those floors. We have just shown one like the model. Can you go to the model? Like even the model shows the beam column layout, and we have all those units. We have mentioned the individual floor foundation loads that are falling on those foundations, and we have used these loads to calculate the loading on our own designed portable foundation system. And based on that, we were able to get a factor of safety above 2 for our design.
Okay, hi. My one question was on the material of the family unit and all of that you have already mentioned. I'd like to ask, because for both thermal comfort and the air change rates, you have said that, okay, this is what is needed in the air change this thing also, that for this room we need X amount or whatever. How have you seen that, whether you have achieved that or not inside your space? Have you seen that?
There was an Excel tool provided for this, so we have entered the ventilation rate and considered the floor height, number of occupants. So all these values have been considered, and then the air exchange has been calculated.
Yeah, air exchange, so you have calculated. So this is what is required. Okay, you will get, how do you calculate the air change rate? You will say that, okay, this is meter square, per meter square I need X amount of air, and then also add for each person sitting there using that how much. Whether you have achieved that or not inside the room is a function of, I mean, it requires some simulation, but it is also a function of how many windows aapne kaise khole hain, how many windows are you giving, and all of that. The Excel tool will give you, probably, I don't know what Excel tool you're talking about, it might be completely different, but if how I understand, like you have said, number of occupants,
right,
this thing per person floor area. So this is what is required as a standard that you are supposed to give. Whether your room has achieved that or not is not evident. This is what you're supposed to achieve. And the same thing I felt for your thermal comfort thing also. You, in your report, you have not presented it here, but in your report you mentioned that, okay, given Delhi's climate, my IMAC range thing is supposed to be between this and this, right? That is what is required as per the climate. Have you achieved it inside the room? For that you require to do a simulation, indoor operative this thing simulation. In the report, it was not so evident. One other thing about the embodied carbon. Okay, my first thought was that, okay, embodied carbon, why did you, since you have to reduce it, why did you use this thing GI sheet only in that, you know? Now you say that that was already present on the site. So are you saying that all the bachelor housing and all of that, for all of that, you get all of your GI sheet and the puff thing from the site itself? You don't have to bring anything new from outside?
Yes, ma'am. So that's what I was saying. Ki, what was already available on the site and what was available in our client stockpile, we've used that, and only what is extra is what we've added to the
Extra in the sense that bachelor pad
is existing base case. Mein, how much material is available? We subtract that amount from what is used in the proposed base case.
Okay. Now in the proposed case, embodied carbon thing, when you figure usme, when you did the calculation for your proposed case, embodied carbon, what did you take as the embodied carbon value of your GI sheet?
Ma'am, the one which was already available to us on the site from the base case, we have taken 0 for that.
Okay.
And what was what we had to use extra, what we have to get from outside, uske liye humne embodied carbon.
Now the thing is that if you are using, I'm just trying to think that one of your objectives was to reduce embodied carbon. Even if you think the amount that you had, you made bachelor pads with that, whatever was extra, you could have thought of some other material. Na? You're using the same material and then increasing your embodied carbon. You know, that is one. And also for your this thing, for your energy performance, why did you say that your energy performance is higher in the proposed case? I thought you said something of that sort. EPI is higher in your this thing.
Not the EPI, but the cooling and lighting load for the proposed case is higher than the base case, since there is more provision of that of appliances and the requirement is higher, since we have provided for all of the 1400 workers.
Okay, that is fine.
Also, if I could just add on the embodied carbon part, only the quantity is changing. For the remaining part that is existing on site, that quantity becomes nullified, since we are not considering embodied carbon for that. The extra quantity that we need, we only calculate for that part and we add it to the calculation. Yeah. Yes.
Okay, so we will start from embodied carbon, same thing. In your report, I think you have made mention about rock wool. Okay, yes, what's the density? 1200. So need to recheck. Did they get the comments whatever we have given?
Yes.
Okay, so you read that comment.
Yes.
So did you check what was the outcome?
It was around 80.
See, just logically, forget. I don't expect very accurate answer. I can tell you the accurate answer. But then imagine you are constructing something. You are using gypsum. Can insulation be heavier than gypsum? No. What is the density of water? 1000 kg per what? Per meter cube. What is the density you have mentioned? Can it be heavier?
No.
Simple logic. I don't expect accurate answer, but then these are small things which can now put exact value of rock wool density and you will reduce your embodied carbon. See what happens now? Huge, 10 times higher you have taken into consideration. That's the reason your results are wrong. It's not accurate. So see, and especially after we commenting, you did not change the calculation. Means you have read it. You did not act upon it. So it's waste of our time. Isn't it? Don't do this. Because see, this is something very serious. See, what happens is, it's a learning for everyone. Okay, tell me one thing. Go to 26, slide number 26. Okay.
Be a bit quick.
All are architect. Is there any engineering student here?
No.
All right, fine. It's okay. U value ka unit wrong hai. And this was also commented. See, nobody generally get into such a tech detail. Why we are saying? Because tomorrow you are going to be professional. You are going to tell people if you do like this. So when the unit is expressed, it means something. U value, conductance, this much watt when the area is 1 meter square in when the temperature difference is 1 degree Kelvin. So this is how it is to be read. So there is slash watt. So this was commented for your report and you again repeated it. So don't do this. So last, dorm. What is the height of the structure? आपका पूरा height क्या है? End to end?
Around 12 meters. 12 meters.
12 meter. So जो second level है, so the person who would sleep, what is the distance from the roof?
Section.
नहीं, just logically सोचो ना, वो 12 है,
At least
3 meter, 4 meter. Take care of comfort. See, the person who is going to sleep, for him it would be unbearable. Just not possible for him to sleep at this level, the last level. And now just relook at whatever observations which has been made about footprint and so many things. See, this is practically very difficult. Yeah. Thanks. Good.
Thank you, jury. It's okay. Thank you, jury. I think these points were important for everybody to take upon and use this in their upcoming designs and upcoming projects that they are going to do. So,
and it's a collective learning, so we are spending time, right? So it's not something we are giving extra time. It's a collective learning. Madam, you just
we have done the calculation. So base case का भी रॉकवूल का हमने डेंसिटी चेंज कर दिया. So the external wall area has increased a lot, and that is why. So the external wall area has increased a lot. There was a lot of partition walls. There was no rock wool insulation used in the partition walls. But yes.
Your previous case, your built-up area was less, right?
Yes.
Then, if you, the reason why your actual number is increasing is because you have built more, right? And you have built more because your logic is that, look, there were less facilities in the previous this thing. We are making an improvement on facilities and all of that. So we have to give more built-up area. More built-up area meaning I have to build more, I have to use more material. So you divide it by the meter square of this thing, then you would get a better this thing, right? Yeah.
Thank you, team. So, thank you, team. Thank you, jury members, for your insightful comments. I think the teams will take upon the comments and use it to their designs in the future timings. So we will have a smaller break right now because we have used quite a bit of time in the previous presentation. So we will resume with the next presentation in the next 2 minutes. we are with our last presentation for today. So now Team Vikram will present their project Setu, located in Mumbai, Maharashtra. Ready? Wait. Go back. Ready? So, team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring this bell like this. And after 20 minutes, I will ring the bell like this. You will not have a 21st minute like the last one, though. Try to complete it in 20 minutes. And then, post that, we'll have a 10-minute Q&A session with the jury and your work. You can start.
Ladies and gentlemen of the jury, esteemed guests and fellow advocates for change, welcome and thank you for joining us today as we embark on a journey to address the dire living conditions of our on-site workers. As we stand here, enveloped by the bustling energy of the vibrant metropolis of Mumbai, it's easy to overlook the harsh realities faced by those who toil tirelessly behind the scenes, constructing the very infrastructure that shapes our own skyline. Mumbai, a city of dreams and aspirations, often fails to provide a sanctuary for those who build its foundation. In Mumbai, where space is scarce, construction workers endure cramped, makeshift shelters devoid of basic amenities, a stark contrast to the skyscrapers they build. How can we ignore their plight, denying them the most basic human rights? Today, we stand to address these injustices, presenting a vision of hope, a future where every construction worker has access to safe, decent housing. Team Vikram has thus partnered with SP Singla Construction and Surat Steel Works. SP Singla Construction are usually involved in building infrastructure projects. One such project is the Mumbai-Goregaon Link Road. Their demand for the worker housing is simple. They wanted their housing to have consideration for families and facilities to take care of workers' children and an increase in the number of users. Team Vikram has thus decided to initiate the project. The site is situated in Mulund, Mumbai. It is a casting yard for mass production of bridge pier caps. The current housing accommodates 150 workers. Total area of the site is 50,000 meters square, out of which 7,300 meters square was provided for housing. The current site conditions are rather poor. No proper waste management, no plinths and pathways, stagnant water on site, and unhealthy living conditions.
In response to the living conditions of the construction workers, we have designed a standardized PPVM module, which is a prefabricated, pre-finished volumetric module. The module as a whole has a capability of expansion in two opposite directions, and due to this, we are able to achieve alternate voids. Once the horizontal arrangement of the modules is done on the site, these spill-out voids can be used as a green pockets for the construction workers. Next up, talking about the design of the housing. The interesting shape of the site has allowed us to create three basic zones, out of which we have three colonies which face to the community facilities. The common facilities basically overlooks into the colonies which we have designed. So the idea was to create inward looking spaces for the construction workers so that there is a sense of inclusive spaces created, and also they feel disconnected from the ongoing site conditions. The common induction spaces overlooks the three zones of our PPVM module housing colonies. The housing as a whole accommodates the basic common facilities like the common dining areas and the common toilets, which are interconnected with the housing colonies. We have meticulously harmonized the green spaces inside the housing. For example, we have incorporated bamboo on the
peripheral edges for screening purposes. And around the toilet areas, we have incorporated neem trees for mosquito repellent. And the site is located near the dumping yard. So in order to reduce the smells, we have also incorporated jasmine and champak trees. So that's the basic design. Talking about the induction spaces which we have designed, the centralized induction spaces can be used as a recreational space by the construction workers to carry out their activities. Plus, we have the interconnecting walkways and social bridges, which are made up of bamboo jalis, connecting all the zones together. For a cost-effective approach, we have incorporated common staircases to connect all the walkways together. And this fosters a sense of community inside the workers. Talking about the PPVM module which we have designed, the module as a whole is a 7 meter by 4 meter module when it's not expanded. This module has a capacity of 4 construction workers to be accommodated. The 4 workers housing can also be used as a family unit by the construction workers. And after the expansion, it has a capacity of 8 construction workers to be accommodated. Talking about the storage for the construction workers, we have incorporated storage units for better facilities there. And the windows are provided on the opposite sides to maintain cross ventilation throughout the module, so that there are habitable spaces created for construction workers which are well lit, and the indoor air quality is also enhanced with the cross ventilation. Talking about the common dining spaces, the common dining spaces has a north light truss which diffuse a beautiful play of light inside the kitchen areas, and there is a sense of openness created by the using of north light truss, and social interaction between the workers is also enhanced. The common toilets and the labs are seamlessly connected with the outer boundary so that the services can be optimized in a better way. The arrangement of one housing module, as I mentioned, we have 3 basic colonies. First colonies, if you talk about one individual colony, one colony consists of 12 PPVM modules, 6 onto the ground floor and 6 onto the upper floor. And due to the horizontal arrangement, we are able to create inclusive spaces in between, and the voids which are formed help us to create green pockets inside the space. So due to the use of the tensile fabric and the bamboo jalis for the social bridges, there is an interesting play of light and shadow inside the spaces. Talking about the green pockets, we have used hibiscus plants for hedging purposes and bougainvillea for vertical gardening to create more breathable spaces for construction workers. Next up, talking about the innovation, the expandability of module is what we are proposing. The modules as a whole has a capacity of getting expanded and accommodate the workers from 4 construction workers to 8. As a whole, there is an effective use of space altogether. Next up, we are proposing pre-installed connections inside the module. As this is a prefabricated module, we are aiming to provide hinged connections for forming the roofs and the walls of the expanded module, so that easy operation can be done once the expansion of the module is done. We have also incorporated steel channels for sliding folding mechanism because we require steel channels to hold the track which we are proposing for forming the floor of the expanded module. The modular design solution allows our module to be assembled on flat terrain as well as contour terrain. That's why it can be assembled very easily on any site conditions. Talking about the material innovation, we have used agri-bio panels, which is made up of 90% straw, and it has been sandwiched with hemp wool and a plywood to allow better insulation inside the spaces.
Our module assembly is designed for simplicity and ease of construction. Using standard steel sections and straightforward nut and bolt fittings, the process begins with the step-by-step opening of the PPVM. Step 1 involves the laying of the tire foundation. Step 2, the outer module is placed. Step 3, attaching of the internal members. Step 4, opening the roofs of the expandable modules which are hinged. Step 5, extending the floor members. Step 6, opening the wall frames of the expanded module. Step 7, laying of the floor plates. Step 8, adding wall panels and roof panels. And lastly, step 9, attaching the window frames and the door frames. Tire foundations have been used for the support of the module. These reduce steel consumption and offer resistance to wind, seismic activity, and other loads. Bracing systems are used in the expandable parts of the module. These reduce the thickness of the steel elements, thus conserving space when the module is folded. Intermodule column-to-column vertical connections include a rigid bolted connection with the help of base plates that connect both modules vertically to ensure structural stability. The original module measures 7 by 4 meters and extends 3.2 meters on both sides. This expansion results in an increase in the surface area, which means that we can get more light and ventilation into the module. The floor consists of a sliding mechanism extension, and the roof has hinged extensions that are supported by diagonal bracing. The windows have inbuilt jars which are hinged from the window and fold upwards for additional protection. Given Mumbai's hot and humid climate, the structure is designed to withstand earthquakes, cyclones, floods, fire, and heat waves. Steel sections ensure strength, and stire foundations enhance anchorage and flexibility. Joineries have been secured using bracings for additional structural support. The use of agribio panels for walling ensures the structure is lightweight. Energy autonomy is achieved through solar panels generating 437.5 kilowatt hours of energy. This is stored in 7 batteries and ensures an autonomy of 75 hours. Considering social resilience, the layout includes women and children-friendly facilities to accommodate the family of workers, fostering relation with local government bodies and public institutions to ensure quick action in case of a hazard. And spaces have been planned such that it creates multiple buffer spaces to allow for interactions among workers to create a sense of community. Now, efforts towards sustainability extend to water management with a significant reduction in baseline water consumption, achieved through lifestyle and fixture adjustments and efficient water management. Our baseline water consumption has decreased significantly from 126 LPCD to 59.2 LPCD. Furthermore, if we exclude the potable water usage, our consumption decreases even more to 48.5 LPCD, which results in a 62% reduction in the consumption of water with a net positive water. Yeah, so potable water sourced from municipal supply and rainwater harvesting undergoes rigorous filtration and treatment processes before it's used. It is then stored in the UGT and the OGT, serving all purposes except for flushing. Then the grey water that's collected from bathing, washing utensils, laundry and cleaning is treated by our with a 95% efficiency by the Jal Sevak solutions machine. Then this treated water is then stored in a separate OHT and then it's given for flushing. The black water from the flushing undergoes treatment in a scalable and transportable STP called the Jokasu STP, and then it is stored in a bore well which is ready for reuse or to be sold to the nearby APJ Kalam Park.
So the initial baseline EPI of the housing is 26.02 kilowatt hour per meter square, which has been reduced to 13.06 kilowatt hour per meter square, thus achieving net positive energy and reduction in energy consumption by 50%. It is done by employing various techniques such as adoption of efficient lighting systems such as LED lights, use of solar water heaters, and use of natural ventilation. And use of solar panels also creates an excess of 25% energy. We have tried to reduce embodied carbon of the project by using shorter span of structural members, lower emission materials, and reducing construction errors by using standard sizes of materials. The module is made using steel sections with 40% recycled content, puff panels for roofing, agribio panels for walls, checkered plate with linoleum finish for flooring, hemp wool for insulation, and UPVC windows for fenestrations. And using these, we've reduced embodied carbon emissions from 375.5 kilograms CO2 equivalent to 154.3, resulting in emission reduction by 58.91%. And Comparison of baseline and proposed carbon emissions of various members shows significant reduction. The site is located in Mumbai, and hence it is important to maintain thermal comfort levels in the module, and we've considered sun radiation, ventilation, and light infiltration in the module. The average interior illuminance in the module is 250 lux with natural light, and the window to wall ratio of the module is 1:10. We have also provided LED tube lights for lighting. The wind flow in the module has been enhanced using cross ventilation, creation of courtyards, and orientation of colonies according to wind direction. Additionally, fans have been used to increase number of comfortable hours. The layout of modules creates opportunities for various spaces to be used as communal spaces, and hence workers can interact with one another, and which helps in their well-being.
The affordability of this project is evident in several ways. Passive earning of thermal comfort and ventilation significantly reduces the energy demand by nearly 50%, further reducing its cost. The use of prefabricated structural steel members provided by our industry partner makes construction easy, fast, and cost-effective. The one-time water setup reduces consumption by 62% with minimal maintenance required. Contractors can store and reuse these modules as needed regardless of the site, making the entire product reusable, enhancing its cost effectiveness. While the design increases the initial capital expenditure, it incorporates low operational expenses, making it cost effective in the long run. The aim of the project was simple: to strategize and construct a workers' housing facility which has net zero energy and is water consumption compliant. To understand the issue, we studied 2 sites in Mumbai and did a couple of online case studies. What we found was that housing facilities were provided for men only and had very poor hygiene. But statistical data showed us that there is an increase in the number of female construction workers. Our project partners also had a special requirement for housing to be provided for women and children as well. Through the above information, we formed strategies based on the end goal of net zero and sustainability. One of them was to reduce the construction time. To do this, we used modules that have adaptability to different sites, expandable modules to increase space to accommodate more people. To improve the quality of life, courtyard spaces for interaction, provision of first aid and banking facilities, and a common dining space for all promotes a sense of equality. To conclude, as architects, it's our responsibility to push the boundaries of what is possible, to challenge the status quo, and to set a new challenge of excellence. Project Setu is not merely an expense, it is an investment in the future of our city and the collective conscience of our society. Our proposal may be ambitious, but it is rooted in the belief that we can and must do better for those who build our dreams. We must ask ourselves, would we be willing to live in the conditions we propose for our construction workers? If the answer is no, then how can we expect them to accept anything less? Thank you.
Really well delivered presentation. Thank you, team. Now we'll move on to the jury for their comments. Just give me a minute. I'll start with Monish, if that's okay.
Very nice presentation. I must say that the quality of spaces that which you wanted to said even in the conclusion sentence, what you said comes across pretty evident. I think the definitely there's no question on the quality of spaces that you wanted to achieve. But also that brings us to this, which you have to answer to the developer and anyone. I mean, for instance, this image itself, looking at the quality, this great as a space, but why steel columns and why tensile over there? Because this is very expensive, and all across, and also the flooring that you're seeing, right? It's a luxury. I mean, and that brings us to the question whether any developer, not particularly this, would be interested in investing and on a project like this. And like I said, I would rather say 9 on 10 for the quality of spaces. But if you look at the master plan again, you have a lot of these, all the periphery you have left out. So in terms of that planning, probably while keeping the same, the aspiration of trying to make something this way could have been looked at from an economics point of view as well. And this is not just for you guys. I think this is something I would say for all the groups. Mostly this project, particularly construction housing or community housing, what we're talking about, is different from other the projects. What really changes is the intent itself. That somebody else is going to make it to make sure that you're getting it's a social project, right? So the cost, why would anybody want to spend on something like this? If you can answer that, you have a great project. And the same thing again, when you were talking about, you are very generous in terms of solar as well. You said 25% more solar. When you're able to calculate it, why would you create 25% more? Because you are spending that much amount of money again on creating solar panels. So when you're doing the sizing, that's the whole point of calculating, right? So why would you spend extra money to create, and who would pay for that? And what is the justification for these things? So I think ultimately that's the everything boils down to that thing about the cost, which you should keep in mind.
So looks impressive, and I think you have already addressed that part about costs. Small observation, since this is in Mumbai and a rainy season, you will have very harsh rain. So how confident you are about your wall construction material, which is agri-based, organic, water absorption, and how sturdy is that? Any thought you have given?
So the agribio panels which we are using, while researching, we got to know that agribio panels are water resistance. So in terms of that, I think that would refer to be as an effective material for walls.
So again, common advice, I think for bamboo usage, we have given similar advice. I have read, I have seen, but there are, such a small thing. Take a piece of paper, try it, burn it, do it, put the water. So these are few small things you can do it. Even though it's a design competition, that doesn't mean something which is very easy to do it ourselves. You will not do it and then just assume something which you have read. So just see if it is possible. That will help you to be more confident while using and choosing the material. That's the comment. Thanks.
Yeah. To mention that while researching for the agribio panels, we actually realized that it's water resistant as well, and it's also fire resistant for up to 2 hours. So in that case, we looked at that point about resilience.
Okay, I have just, I think one point I would again keep for after, because that's common to all. So I'll keep that. The one point that I wanted to ask, and that's what I was also asking you, Monish, is that, you have this expandable thing and it expands. Once you expand it in the corners, you don't have anything support to the ground.
Yeah,
or
we
do
are
you?
supporting the hinged supports for the expanded part, because the expanded part needs to be supported. So we have.
Did you? Yeah, that's what I was thinking, because it's not just even one story. Okay, it is you are having 2 stories. So the entire thing. So that's what I was a little confused about.
When I mentioned about the connections, we have explained it with a simple diagram about how we are planning to support the expanded part.
Okay.
We'll just get to that point. So yeah, that one next. So after expansion, the hinged part will eventually support the expanded part.
This is a section.
Yeah, that's a section. Yeah.
And it comes out and it
supports the expanded
part on the ground.
On the ground, yeah.
I'm not very sure if it will be enough, and That's the only thing.
On
I mean,
both the ends it supports, but we have provided the tire foundation as a whole to support the main
the
PPK
main
model.
thing,
Yeah,
right?
the
Because here
main
it is
PPK.
it's concentrated in a very small area, right?
Yeah.
So just the idea of it, that the fact that it expands and everything, it's great. But once it expands, and it's not just one story, it's two stories, right? So it's one on top of other. So that's a little bit of a, like, will it support or not? That is the question. And the other point, again, I think I'll take it later, the second point, that because that's common for
Our
everybody.
main reason for taking just the 4 tire foundations was so that to reduce the cost of excavation, so that that foundation would reduce its cost in general. So the expanded part could just simply be supported otherwise. If it works.
Yeah. What's the duration of project?
Currently 3 years, yeah.
3 years?
Mentioned that your load, the passive thing, reduces by 50%, correct? From the base case. How? Because what is excess in the base case that you're able to reduce and bring it down by 50%? But you have the same the fans and the same systems, I suppose. So how can it reduce by 50%? Can you just explain how did you arrive at that?
Actually, we have used effective fixtures when it comes to the energy performance. So they used the proposed, the baseline was, yeah.
We will talk about it.
Okay, works.
We proceed.
Yes.
Thank you, team. So it's time for some learning and some questions from the audience and maybe from the jury also. As Saraswati said, she has some questions, some suggestions that she might want to give. I would rather go.
All right, so all the teams are here? All the 6 teams are here? Okay. So can I ask each one of you to kind of think that in your energy performance numbers, when you say that, okay, this is the base case energy performance, this is the proposed case energy performance, what did you change from the base case to the proposed case? You have some EPI, na? In all the cases you had base case EPI, proposed EPI. What did you change to get that reduced EPI? One by one. I think this is one team. I think this is Eco Orb. Yeah, that is Samarthan. Right. What did you change?
The number of openings inside the module, as well as the appliances used inside the module, like the type of fixture, and then how it is going to perform in terms of the natural ventilation, as well as the number of use of number of hours of lighting should be reduced to get lower
Okay.
EPI. So that was
Now, generally, what everybody has done, even though you say that you have done the openings and all of that, if you see in terms of calculation, that what you have shown is, okay, I have used this LED, this wattage in the base case. In the proposed case, I have used a different LED of which is much better efficiency, low wattage, better lumens, and similarly efficiency of your fan has been made well, more efficient and all, right? So what you are doing here in reducing EPI is just change the fixtures. You have not taken into account the design of it. Now I understand also that this is a division in which you cannot say that, oh, my base case, I have used this type of material, I'm going to air condition building. That is never going to happen, right? That will not be acceptable also, right? So narrative kya banaoge? What will your narrative be? Because if I'm not using any air conditioner at all, then how do I energy efficient? Because, you know, so there I think in this division specifically, the idea of thermal comfort becomes very, very important, more than the energy numbers, because energy performance numbers, even in the base case, the builder won't care that whether this person is thermally comfortable or not, right? They are not going to say that right now, because of GI sheet being used, temperature is going to be 30 degrees Celsius, let me air condition it. And if I'm using insulated this thing, my inside temperature comes down to 28 degrees Celsius, so now I don't need to air condition it. No one is going to see that. The builder doesn't care whether he's in the construction worker is on 34, 36, whatever. So in construction housing, the narrative I think has to come from the thermal comfort side of things. And that is where I think, except for 2 teams, nobody even touched upon that subject. It was like, daylight kar liya, thermal comfort, diya hai, how? Evidence based. And I'm not saying that that did handle it. I did not check whether the numbers were correct or not, because simulation models were not in front of me or whatever, but at least it was there. So the narrative could be that in my base case, by X number of hours were comfortable. In my base case, in the proposed case, I have improved the number of comfort hours. So hypothetically, I will need to cool my base case. Hypothetic, if you were giving thermal comfort all the time, I would need to provide this much, I will need to provide that much. Because right now the case has come for certain this thing. Why are you even providing insulation or on your roof or something like that? Because by use of fixture, though, your energy performance has been improved. So why will the builder say, no, instead of regular this thing, please put Ricron panel and insulation? Because the evidence has not been given there. So, I mean, one basis of one way in order to justify this is embodied carbon, yes, but I'm not very sure how much for construction workers housing, how much of a thing that will be. So embodied carbon, thermal comfort, and if people have worked on, and most of you have worked on, the reusability of this thing. So that I think needs to be like, that is the kind of selling point overall. But my point here was that, in terms of energy performance and thermal comfort, those two are very closely related, especially for this construction worker housing. So I think next time, if any from your colleges attempt this, I think that is something that you will need to upskill yourself on, that how do I get the thermal comfort hours, operative temperature hours inside the space.
Anything, Nilesh?
So I think Monish is very, very vocal about density, and such a diverse projects. 150 numbers last presentation, number of occupant to 1400 just before the break, I think, Satwa, right? So see the range we are providing accommodation to, and if you see the cost number again, 6,000 rupees per meter square to 28,000 rupees per meter square. You see, just imagine if I'm a developer, you are a developer, and you have to construct something, and you see, these are the people, nobody would like to provide extra money, shell extra money to construct something. At the same time, there is again a responsibility of providing comfort, as madam said. So how will you achieve that balance? See, that's a golden mean designer need to address. So while the number for 1400 occupants, that looks higher, but if you see the rupees per meter square per person, probably they are least, though they need to do those changes in terms of providing comfort for the people who are staying in dorms. But then look at it this way, eventually it boils down to how much area the entire project is going to occupy. You see, Ahluwalia has 100 acres of project area. You are occupying 1 acre, 1 entire acre, right? So 1% looks fine, but just imagine the shipyard project. There is no space available, and if you are going to occupy say similar area, or let's say even half acre, there is no land available. So just pay more attention what kind of area we are using, what is the density. So that's from probably project point of view. But then see, one common guideline: be very passionate what you are presenting, and the only one way to be passionate about it is don't read like this. Doesn't look nice. See why? I'll tell you. The moment you are going to read it, your confidence will be half. Just look at in the eyes of people, jury members, or your fellow peers, and be confident. If you have developed everything on your own, you will achieve and develop that confidence to talk. So just reading, using piece of paper, fine, you can have pointers, but don't read, because now you are a fairly mature professional now, right? So that's a common advice. So next time how you will mentor your next batch, all these points we need not repeat them, right? Thank you so much. Lovely presentations all. Thanks.
Monish?
I think before anything, all of you deserve a huge round of applause for yourself. Great job overall. I'm sure you'll get better with numbers, and we all do when you start with something. But this trajectory is very interesting and it's essential. And this is a segment that is ignored. I think we all accept that, construction, housing, and all that. And India is a growing nation. We all know that. Looking at the aspiration to build, how much we are wanting to build, and this is something which we cannot be ignored anymore in the future. But one thing is common in projects like this, whether it is construction housing or social projects which are there, or affordable housing, anything that you're talking about. While definitely going forward, we will be discussing about carbon and the thermal comfort and all of that. But to make anything viable, I'm just adding on to what Nilesh also just mentioned about the costs and all of that, because that's one parameter. If you cannot address, that's the red flag or the red tick, whether it goes forward or backwards, or it didn't. Got it? So I think all of you have done, I think, extremely well overall in terms of trying to get your concepts right. You're, I think, like I said, fantastic work overall. But things like this really matter about the density at the master plan level itself. Even before you get into the design and make it draw a single line, if you're putting your thought into how much you're addressing the numbers in terms of the master plan and all of these things correct, these are things that you can resolve with design, and then it goes into the analytical process of trying to optimize the design. The first one is more on the lines of trying to just what design can do in what you're actually bringing onto the table. Then goes into the process of how do you optimize it to make it better performance, and better everything after that. Okay. All the best, guys. Thank you. And on a closing note, I'm sure if even any of the designs, what you guys did, goes out there and gets built, it will be far better than what's already existing. Okay. Good job.
Obviously. Thank you. With this, we end our presentation for Construction Worker Housing Division. Our esteemed jury panel here have shown immense dedication and assessed your work from the past 3 weeks and also now the whole day. I want to thank the jury members for their thoughtful assessment and comments. And finally, I want to congratulate all the finalists present here. As a jury coordinator of this division, I have seen the teams submitting their deliverables, their work over the years. Let's not forget that these teams have been working for the last 9 months, figuring out how to collaborate with other people, integrate design, integrate engineering, integrate other systems into their buildings, and foster different type of knowledges that they can get through. So for at least that, I think we need to give applause for everybody present here, having been doing work for the last 9 months. with this evening, the jury members will meet and decide the winner and the runner-up teams. Any guesses? Who will it be? Don't tell. Keep it with yourself. While in anticipation, don't forget to head to our YouTube channel to vote for the best movie. We have extended the timeline till 5 o'clock today. Up next, we have an exhibition called the Climate Smart Exhibition, where you will get to see innovative building products that are addressing climate change. The exhibition is now open for all. Please proceed to the multiplex zone, which is about 5 minutes from here. And for the people online, stay tuned to our channel at 6 o'clock today evening. Watch the 10 exhibitors pitch their product to bid for the Climate Smart Innovation Award. Until then, have a good evening. Thank you all.